Hello there and welcome to Life Beyond Scene, where curiosity gets comfortable, the world gets a little quieter, and tonight's subject comes wrapped in mist, distance, and the sort of caution that tends to make scientists clear their throats before speaking too confidently. This evening we're heading toward the Amazon, though not in the usual postcard fashion. Not the bright brochure version with a riverboat, a few parrots, and someone smiling bravely in a beige hat while pretending the humidity isn't actively trying to dissolve their will to live. No, we are drifting toward the deeper question, the one that lingers at the edge of maps and field notes and satellite images. Why do scientists, people whose entire profession is built around going toward the unknown, still avoid certain areas of the Amazon? It is a curious thing, isn't it? We live in an age of satellites, drones, thermal imaging, machine learning, GPS, portable labs and watches that can tell us we are stressed even when we were hoping to remain politely in denial. We can photograph galaxies that sit impossibly far from Earth. We can track storms from space. We can map the seafloor with increasing detail. We can send robots into dangerous places and sensors into hostile environments. And yet, on our own planet, in one of its largest and most famous rainforests, there are still stretches of land where scientists hesitate, delay, reroute, or sometimes simply decide that today is not the day to go marching in with notebooks and noble intentions. That does not happen because science is timid. It happens because reality is often less cooperative than a documentary narrator makes it sound. In the comfortable distance of a screen, the Amazon can seem like one vast green place, mysterious but unified, dense but understandable, wild but available to anyone with enough funding and insect repellent. From a sofa, from a bed, from that little pool of evening light where you may be listening right now, it is easy to imagine the forest as something waiting to be explored in a tidy sequence. First the boat, then the hike, then the close-up of a leaf, then the dramatic discovery, and finally a well-earned cup of tea, presumably served somewhere with excellent ventilation and no mosquitoes at all. The real forest, quite rudely, has other plans. Before we go any further, I would love to know where in the world you're listening from tonight, and what time it is in your corner of it. It feels fitting somehow, a story about a place so immense and difficult to enter, arriving to each of us from entirely different rooms, different cities, different weather, different hours of the night. Some of you may be listening beneath rain tapping at the windows. Some may be under the dry hush of a late evening where everything outside has already gone still. Some may be curled into blankets while the house settles around you, in those little sounds homes make when they believe no one is paying attention. And somewhere, perhaps, someone is listening in the middle of the afternoon, heroically pretending this is definitely not the sort of voice that could make a person drift off halfway through a sentence. If you find this gentle journey soothing, or intriguing, or simply a pleasant way to let your thoughts slow down a little, I would be very grateful if you gave the video a like, and maybe subscribed as well. It helps this small and sleepy corner of the internet reach other curious minds who might also enjoy ending the day with a long wander through the stranger edges of the world. And as always, I do hope this is calming enough to help you rest. Though if you do stay awake all the way through, at least you will leave with a renewed respect for the number of things in the Amazon that can sting, bite, infect, mislead, conceal, flood, isolate, or simply make a sensible researcher take one look at the situation and mutter, "Perhaps we should circle back to this after a great deal more planning." The Amazon has a way of shrinking and enlarging in the imagination at the same time. On the one hand, everyone has heard of it. It is one of those names that arrives already carrying weight, the Amazon. Even saying it feels like invoking something too large to fit inside a normal sentence. It summons images quickly. Endless green, thick canopy, river water the colour of tea, strange calls in the distance, trees taller than buildings, creatures with too many legs or too many teeth, or in some cases both. But on the other hand, familiarity is deceptive. Knowing the name is not the same as knowing the place. The Amazon is not a single uniform block of forest. It is an enormous, complicated region spread across several countries, threaded with rivers, divided by terrain, shaped by rainfall, seasonality, remoteness, human history, politics, danger, access, and the endless stubborn detail of actual geography. That last part matters. Geography sounds so calm when written in books. In practice, it can be deeply inconvenient. A line on a map does not tell you what it feels like to move through heat that presses against the body like wet fabric. It does not tell you about mud that seems to form a personal attachment to your boots. It does not tell you how quickly equipment fails when everything is damp, how far a simple river bend can be from help, how the wrong insect bite can become a serious medical problem when the nearest clinic is not just around the corner, but many hours or even days away by boat, depending on weather, water level, fuel, and whether the route itself is passable. This is one of the first things that often surprises people when they begin to look at the Amazon not as a symbol, but as a working environment. It is not merely vast, it is operationally difficult. Those are not the same thing. A desert may be vast and still allow visibility. A mountain range may be harsh and yet offer fixed routes. The open ocean is dangerous, of course, but at least it is open. The Amazon is different. It encloses, it obscures, it slows, it absorbs effort, it turns distance into a far more personal problem than many maps would suggest. A straight line means very little when there is no road, no clear trail, no reliable communication, no dry ground, no easy extraction, and no guarantee that conditions will remain even vaguely similar from morning to afternoon. Scientists know this better than most, because for them, the forest is not a backdrop, it is a working reality. To study a place properly, one does not simply wave at it from a canoe and declare the matter investigated. Real field science demands repetition, measurement, transport, setup, maintenance, retrieval, comparison, and patience. It demands that instruments reach the site intact. It demands that samples stay viable. It demands that data not vanish because a battery failed, a sensor flooded, a path washed out, or a whole carefully arranged plan met the ancient and unbeatable force known as the weather has changed. And in the Amazon, the weather has a rather confident personality. It is worth remembering that avoid does not always mean fear, in the simple sense. Sometimes it means respect. Sometimes it means practicality. Sometimes it means ethics. Sometimes it means that even if something can be done, it should not be done casually, intrusively, or at all. The reason certain areas remain lightly studied is not one reason, but several layered together. Some places are physically hard to reach. Some are biologically hazardous. Some are politically sensitive. Some are culturally protected. Some contain isolated indigenous communities whose safety depends precisely on outsiders, not arriving uninvited with backpacks, drones, and a bright idea. Some regions are affected by illegal activity, logging, mining, trafficking, land conflict, or armed groups, making them unsafe not because of the trees, but because of what human beings have chosen to do in and around them. Already, the Amazon begins to look less like a single mystery, and more like many different kinds of difficulty sharing the same immense address. There is also the matter of scale, which sounds obvious until one sits with it for a moment. The Amazon rainforest covers millions of square kilometers. Even saying that number can flatten the reality of it, because very large numbers are strangely bad at producing feeling. The human brain can emotionally grasp a room, a road, a city block, perhaps a valley if the weather is good and one has had a decent breakfast. But millions of square kilometers is the sort of size that slips free of intuition. It becomes a fact without texture. To scientists trying to understand biodiversity, climate, hydrology, disease ecology, archaeology, soils, carbon cycling, species distribution, or the movement of isolated peoples that scale creates a basic problem. No single team can be everywhere. No survey is ever complete. No map is final for very long. There are simply too many rivers, too many tributaries, too many variations in terrain and seasonal flooding, too many different microhabitats, too many species interacting in ways that are local, dynamic, and often hard to predict. And beneath all that lies an important point that tends to hide behind the romance of exploration. Being underexplored is not the same as being untouched, and it is not the same as being empty. The Amazon has been inhabited, travelled, modified, managed, cultivated, named and known by indigenous peoples for thousands of years. Scientists are not approaching a blank page. They are approaching a place with deep human histories and living communities, many of whom know the land in ways formal science is only beginning to appreciate properly. Sometimes outside researchers avoid certain regions because entering them without permission would be dangerous and disrespectful. Sometimes they avoid them because contact itself could bring disease to isolated groups with little immunity. In those cases, staying away is not a failure of curiosity. It is a recognition that knowledge does not entitle intrusion. There is a quiet lesson in that, one the modern world still needs. We often speak as though more access is always good, more information always better, more reach always justified. But some places impose limits that are not merely logistical. They are moral. A scientist may wish to know more about a region, its biodiversity, its soils, its past settlements, its unrecorded species, its water chemistry, its hidden archaeological traces. Yet wanting to know is not the same as having the right to arrive. The forest, or the people within it, may answer with a firm and reasonable no. Still, even where permission is granted and intentions are careful, the Amazon remains a demanding partner in any scientific relationship. Equipment behaves badly. Electronics dislike humidity. Paper dislikes humidity. Clothing dislikes humidity. Human moods, though less often discussed in polished scientific summaries, also dislike humidity after enough days have passed. Then there are river levels that rise or fall beyond expectations, aircraft access that depends on weather windows, engines that fail at awkward moments, supplies that must be packed in and packed out, and the constant requirement to think several steps ahead, because improvisation becomes much less charming when you're far from help and surrounded by 1,000 square miles of persuasive vegetation. This is perhaps one reason the Amazon continues to occupy such an unusual place in the scientific imagination. It is not merely a source of data, it resists simplification. Every answer seems tied to 10 more conditions. Every discovery appears connected to a chain of details that makes broad statements risky. A researcher might identify one species in one patch of forest, under one set of seasonal conditions, and still be very far from understanding how that pattern holds, or fails to hold, elsewhere. The forest is full of local truths that do not always scale neatly upward. Science likes patterns naturally. The Amazon keeps offering exceptions, and yet, that is part of why the place matters so much. Scientists keep returning, planning, recalculating, collaborating, adapting, because the Amazon is not just another green area on the map. It is one of the most biologically rich regions on Earth. It influences rainfall far beyond its own borders. It stores enormous amounts of carbon. It contains countless species, some known, some poorly understood, some not yet formally described. It preserves clues to past climates, past human settlement, past ecological shifts. It shapes weather systems. It affects fisheries, agriculture, disease dynamics, and global climate discussions. In short, even its hardest to reach areas matter. Perhaps especially those areas. The challenge is that importance does not make access easy. It merely makes the difficulty more consequential. You can begin to see the tension already. On one side there is scientific urgency. On the other, there is material reality. There are places people want to study because those places may reveal how ecosystems work, how forests recover, how species adapt, how disease spreads, how human societies interacted with the landscape long before modern observers arrived. But the deeper one looks, the clearer it becomes that wanting data and obtaining it safely are not the same enterprise. A satellite image may hint at unusual structures beneath the canopy. A remote sensor may suggest a hydrological pattern worth investigating. A set of older records may point to a region rarely sampled. Yet between that interest and an actual field expedition lies a long chain of preparation, permissions, transport, funding, local collaboration, medical planning, contingency planning, and the quiet acceptance that even the best plan may still lose an argument with the forest. That, in part, is what makes this subject so compelling. We're accustomed to stories in which science advances by steadily shrinking the unknown. A little less mystery each year, a little more certainty, another blank spot filled in. But the Amazon reminds us that knowledge does not always move in a straight line, and the world does not yield all its detail simply because we have become technologically clever. There are still environments where the most advanced response is caution. There are still places where expertise begins by admitting limits. There are still corners of the earth where scientists, for all their instruments and training, must contend with the simple fact that entering is hard, remaining is harder, and understanding may take far longer than any impatient modern timeline would prefer. That may be why the question catches the imagination so strongly. Why would scientists avoid anywhere when their work is built on looking closely? Because sometimes looking closely is costly, sometimes it is dangerous, sometimes it is unethical, sometimes it is all three at once. And in the Amazon, those reasons often overlap in ways that make the decision not to go, or not to go yet, or not to go there specifically, far more thoughtful than it first appears. As we ease further into this story, we will see that the problem is not just one of snakes or spiders, or the occasional unsettling sound in the dark, though the forest is certainly not short on creatures capable of making a field notebook tremble in perfectly understandable ways. The larger issue is that the Amazon presents a layered challenge. It can block access physically, technologically, medically, politically, and morally, often at the same time. A river may be navigable in one season and impossible in another. A region may be biologically fascinating and also too risky to enter without creating serious danger to isolated communities. A survey may seem straightforward until the canopy interferes with remote sensing, the humidity ruins equipment, and the nearest evacuation route begins to look less like a plan and more like an optimistic sketch. For now, though, let us stay with the threshold. That first uneasy sense of why a place so famous can remain, in practical scientific terms, partly out of reach. Not hidden exactly. Not lost in some melodramatic sense. Just difficult in ways that resist easy storytelling. The Amazon is known and unknown at once. Named, mapped in part, studied in part, inhabited, contested, threatened, admired, and still not fully accessible even to those trained to study difficult places. It sits there, immense and alive, asking a great deal from anyone who wishes to understand it properly. And perhaps that is where the real story begins. Not with a dramatic leap into the jungle, but with the quieter recognition that some landscapes do not open on command. Some places remain hard because they are hard in fact, not just in legend. Some remain lightly studied because reaching them requires more than courage. It requires permission, preparation, luck, restraint, local knowledge, and an acceptance that the forest has every intention of being itself, whether or not anyone arrives with a grant proposal. So, settle in a little deeper, and let the room around you soften if it wishes. We are only just approaching the tree line, and already the Amazon is making its point. For all our maps and machines, there are still parts of the world that do not hurry to explain themselves, and when scientists stop at the edge, it is rarely because the questions are unimportant. More often, it is because the place beyond that edge is larger, harsher, more delicate or more complicated than outsiders first imagine, and the deeper we go, the clearer that becomes. If the Amazon were merely large, scientists would have solved more of it by now. Large, on its own, is manageable. Humans are good at large when large stays still, stays open, and behaves with the decency of a landscape that can be seen from one end of the problem to the other. A desert is large, but you can often look across it. An ocean is large, but at least it does not pretend to be 1,000 different rooms stacked on top of each other, dripping, buzzing, rotting, growing, and hiding things in layers. The Amazon does exactly that. It is enormous, yes, but it is also crowded in every sense. Crowded with species, crowded with moisture, crowded with rivers, crowded with terrain that changes by season, crowded with practical difficulties, crowded with histories that are deeper than many outsiders first assume. That is one reason it keeps slipping away from any easy claim that it has been fully studied or neatly understood. WWF describes the Amazon biome as the world's largest rainforest, and notes that it holds around 10% of the world's known species, which is already enough to suggest that any attempt to summarize it in a few clean sentences is going to end badly for the sentences. And then there is the little matter of what known even means. It sounds simple until you try to pin it down. Does knowing the Amazon mean mapping where the forest stands and where it has been cut? We can do some of that. Does it mean identifying its tree species? Scientists have made major progress there, yet even that work has required constant correction, curation, and revision. A taxonomically verified checklist published in PNAS compiled 14,000 3C plant species for lowland Amazon rainforests, including 6,727 tree species, precisely because earlier large floristic data sets contained serious errors and inconsistencies. In other words, even the question of what is growing there has needed careful rebuilding from the ground up. Now, 14,003 seed plant species sounds wonderfully precise, the sort of number that makes a reader sit back and think, good, that's settled then. It is not settled, it is progress. Those are different things. Another study on Amazonian tree richness pointed out that sampling at the scale available for such a huge region was vanishingly small, about 0.00035%, and that common methods can badly underestimate total richness when sampling is far below what would be needed for full coverage. That is a very scientific way of saying that the forest is still ahead on points. Part of the difficulty is that the Amazon is not one forest in the everyday sense of the word. It is not a single green blanket doing one consistent thing across one consistent kind of land. Scientists working on Amazonian tree biogeography have shown that species composition changes across the basin in relation to environmental conditions such as hydrology and soil nutrients, and that even the old idea of major rivers acting as straightforward biological dividers does not always hold cleanly across all taxa. Some rivers matter a great deal for some organisms, for others, less so. Some patterns that look obvious at one scale blur at another. The result is not one giant answer, but a patchwork of local answers that refuse to become tidy just because a human being would very much like them to. This is where the imagination often trips. People picture the Amazon as uniformly dense, uniformly wet, uniformly hard to access, and uniformly mysterious. That image is understandable, but it is misleading. There are floodplain forests, upland forests, bamboo-dominated areas, seasonally dry patches, white sand forests, river edges, heavily studied reserves, indigenous territories, zones altered by ancient human settlement, areas damaged by logging and fire, and areas that remain extremely difficult for outsiders to sample repeatedly. A scientist may know one site very well, and still know remarkably little about another site that looks, from high above, as though it ought to be similar. The forest can change its terms of engagement from one watershed to the next. Even the practical business of collecting data is full of traps. Ecologists do not study a rainforest by staring meaningfully into the middle distance and hoping the biodiversity introduces itself. They need field plots, repeated visits, vouchers, sound recordings, camera traps, insect traps, water samples, soil samples, canopy access, local permits, transport, storage, backup plans, and people on the ground who understand where a map stops being a map and starts becoming an inconvenience. and yet field studies in Amazonian landscapes can be badly biased by where it is feasible to work. A PNAS study found substantial biases, ranging from 9 to 98%, when forest structure and biomass estimates from typical field plots were compared with the wider landscapes around them. Worse still, the number of 1 hectare plots required to reduce those biases to something comfortable was often impractical. That word, practical, does a lot of heavy lifting in rainforest science. In a laboratory, practical might mean whether the freezer has enough space and whether someone remembered to label the tubes. In the Amazon, practical can mean whether the river is high enough to pass, whether the motor will start after a night of rain, whether a supply line can be maintained, whether the nearest medical help is near enough to matter, whether a team can reach the site and return with the samples intact, and whether the same site can be revisited often enough for the data to mean more than "we were there once and everything was damp." That is not scientific pessimism. It is fieldwork with its shoes on. Accessibility shapes knowledge more than people like to admit. Researchers at the University of Leeds noted in a 2023 policy brief that financial and resource limitations have historically pushed ecological research toward more accessible parts of the rainforest, often those closer to research institutions. A 2026 study summary on Amazonian biodiversity said much the same in sharper terms. Accessibility drives research effort, and targeted surveys in remote areas, especially with local traditional communities, are essential for building a more complete understanding of biodiversity. In other words, the places easiest to reach are often the places easiest to know, and the places hardest to reach are left holding a disproportionate share of the unknown. There is also the vertical problem, which is not discussed nearly enough for a forest built like an apartment block. The Amazon is layered. What happens on the ground is not the same as what happens in the understory, and neither is the same as what happens in the canopy. From below, the canopy blocks light, sight, and often common sense. From above, it conceals much of what sits underneath it. Scientists have had to work harder than one might expect simply to understand which trees dominate in different forest strata. A large collaborative study highlighted by Florida International University reported that the dominant species in the canopy differ from those in the understory, which sounds obvious once said aloud, but the point is that even basic structural understanding required an enormous data set and large collaboration. The forest is not just broad, it is stacked. Technology helps, of course. It helps enormously, but it does not solve everything, and that is one of the more sobering lessons modern science keeps learning in the Amazon. Remote sensing has transformed rainforest research, yet review work in 2024 still emphasised that constrained spatial and temporal coverage, resolution limits, and the challenge of representing fine-scale physical processes in broader models continue to restrict what scientists can confidently infer. Another study on tropical forest degradation noted that understory disturbances are especially hard to map because leafy vegetation can recover quickly. Many disturbances happen below the canopy, and conventional reflectance-based remote sensing can miss them. NASA and JPL have made similar points for years in relation to understory fires, which can burn beneath treetops and remain partly hidden from satellites designed to detect more obvious active fires. So yes, we have satellites, radars, and LiDAR, and they are extraordinary tools. The forest still finds ways to duck. That is why new methods often reveal not that the Amazon is finally understood, but that it was more complicated than the previous method allowed anyone to see. LiDAR, for instance, has been a small revolution in places where canopy cover once defeated ordinary observation. NASA's airborne laser work has provided three-dimensional measurements of Amazon forest structure that were previously unavailable at scale, and archaeological work published in Science used LiDAR to reveal large numbers of previously undocumented pre-Columbian earthworks. That study estimated that more than 10,000 such earthworks may still be hidden across Amazonia beneath remaining forest cover. If ancient structures on a large scale can stay concealed that long in one of the world's most discussed landscapes, it should probably keep the rest of us modest. The same humility applies to animals. The Amazon is famous for charismatic species because human beings are by nature easily impressed by anything with bright feathers, long teeth, or a face that appears to contain judgment. But many of the most important gaps in scientific knowledge involve less glamorous creatures, smaller species, local endemics, freshwater life, insects, fungi, soil organisms, and species complexes that only reveal themselves as multiple distinct species when someone finally looks closely enough. Electric eels are a perfect example. For a very long time, many people thought of the electric eel as one iconic species. A 2019 study in Nature Communications found that there are actually 3 species of Electrophorus occupying different regions. So even among animals that seem famous enough to deserve their own dramatic soundtrack, the Amazon still has a habit of saying, "Not quite, try again." Freshwater systems tell a similar story. The basin's fish diversity is immense, unevenly distributed and far from fully inventoried. A 2021 Scientific Reports paper on Amazonian fishes described tropical diversity as still partly undescribed and noted that vast reaches remain unexplored. A 2025 PNAS paper on fruit-eating fish diversity went further, stating plainly that fish inventories are far from complete in tropical freshwaters and identifying the Amazon basin as a case of heterogeneous and incomplete sampling, which means that in rivers that have carried people, goods, myths, pathogens and entire human histories for centuries, science can still arrive late and find that the cast list is unfinished. There is a deeper reason for this stubborn incompleteness, and it is not just that the forest is hard to enter. It is that the Amazon generates difference. Rivers separate some populations and connect others. Soils select for one community here and another there. Flooding changes the terms of life by season. Elevation, drainage, sediment, drought history, fire history, canopy gaps and human land use all shuffle the deck. Species turnover is not a side issue. It is the point. The forest keeps making many versions of life in many versions of place. That is wonderful for biodiversity and awful for anyone hoping to finish the paperwork. And then, quietly, there is time. Not in the cosmic sense this time, but in the much more irritating research sense. Good science needs repeated observation. One dry season is not 10. One flood pulse is not a century of flood pulses. One inventory trip tells you what was detectable on those days, under those conditions, with that method, by that team. It does not automatically tell you what the site is in a fuller sense. The Amazon changes across wet seasons and dry seasons, across El Niño years and non-El Niño years, across disturbed and recovering forests. Review work on tropical forest disturbance has emphasised how drought, fire, logging and edge effects interact, and how difficult it still is to monitor their ecological impacts fully. That means that part of the Amazon's refusal to be fully known comes from the simple fact that it will not sit still long enough to be captured by one pass of human attention. There is also an uncomfortable truth that has nothing to do with the trees themselves. Sometimes the unknown persists because scientific capacity is uneven. Research stations need funding. Local institutions need support. Collections need maintenance. Long-term monitoring networks need staff, transport, equipment, and political stability. Without those, knowledge does not just advance more slowly. It becomes patchier, more fragile, more dependent on the few sites that can still sustain regular work. Recent reporting on research infrastructure in the Amazon has shown how strained some institutions are, which matters because one of the easiest ways for a forest to remain partly unknown is for the people best placed to study it to be asked to do too much with too little. And yet, it would be wrong to tell this story as though the Amazon is unknowable in some grand and mystical sense. That would let us off too easily. It is being studied all the time. Scientists have built remarkable networks, checklists, plot systems, remote sensing programs, archaeological surveys, genomic projects, and long-term data sets. The point is not that the forest cannot be known at all. The point is that it resists being known quickly, cheaply, evenly, or from a distance. It punishes overconfidence. It exposes sampling bias. It makes broad claims expensive. It reminds researchers that a map of effort is not the same thing as a map of reality. This is why the Amazon has a particular reputation among scientists, not simply as a difficult field site, but as a place that keeps revealing how much method matters. Go only where access is easy, and the picture bends. Sample only what is visible, and the picture bends. Trust only what satellites can see, and the picture bends. Ignore the understory, the floodplain, the small streams, the remote interfluves, the ancient human signatures under the canopy, or the knowledge held by local and indigenous communities, and the picture bends again. A forest that big does not hand out truth in one piece. Perhaps that is the most honest way to describe it. The Amazon refuses to be fully known because it is not waiting passively for a single grand explanation. It is a basin of many systems, each complicated enough to deserve its own careful patience. It is still producing new data, still forcing revisions, still surprising people who thought famous meant familiar. In one corner, a plant list gets corrected. In another, hidden earthworks appear under laser scans. In another, remote sensing improves but still misses what lies beneath leaves. In another, field plots turn out not to represent the surrounding landscape as well as anyone hoped. In another, a fish, an insect, or an eel discovers the pleasure of becoming several species instead of one. So when people say the Amazon is still not fully known, they are not admitting defeat. They are describing a working reality. They are saying that one of the largest living systems on Earth remains larger than any one method, any one data set, any one generation of field campaigns. They are saying that the forest keeps part of itself beyond immediate reach, not because science is weak, but because the object of study is immense, layered, and unevenly accessible. They are saying that knowledge here comes in fragments, roots, returns, corrections, local partnerships, long records, and patient accumulation. And once you see that clearly, another question begins to come into focus. If even the basic work of knowing the Amazon is shaped so strongly by access, then what happens in the places where access itself breaks down, where distance, terrain, river routes, and simple logistics start deciding what can and cannot be studied at all? Because the next problem is not just that the forest is complicated, it is that large parts of it remain far away in the most practical, exhausting, and expensive sense of the phrase, and that is where the green on the map starts turning into something much more stubborn. Once you begin to look at the Amazon the way researchers do, the map changes. It stops being one great block of green and starts becoming something stranger and more uneven. Some areas are thick with studies, repeat visits, plots, inventories, and long-running projects. Others are green in the same way on the screen, but thin in data, thin in field presence, thin in repeat sampling, and thin in the kind of practical familiarity that turns a place from a mystery into a working field site. That is what many of the blank spaces really are. Not empty land, not land without history, not land unknown to the people who live there or have lived there for centuries. They are blank in a narrower and more revealing sense. They are places where scientific coverage is sparse, irregular, or badly biased by the simple difficulty of getting in, getting out, and getting back again often enough to build real knowledge. A 2023 current biology study that compiled metadata from 7,694 ecological sampling sites across the Brazilian Amazon found that accessibility and proximity to research facilities strongly influenced research probability, and that 15 to 18% of the most neglected areas are expected to face severe climate or land use change by 2050. In other words, some of the least studied places are also among the places changing most quickly. That is the first important correction to make. A blank space in Amazonian science is usually not blank in life. It is often a place where the forest is still inhabited, travelled, fished, cultivated, remembered, named or protected, but where formal scientific work has not kept pace. Sometimes that is because access is hard, sometimes it is because funding is patchy, sometimes it is because long-distance logistics drain time and money so quickly that a team can only visit once, or visit a few reachable sites and leave the deeper interior alone. Sometimes it is because responsible science has to stop at the boundary of territories where outsiders cannot simply arrive because they are curious. And sometimes it is because modern observers are still discovering how much of the Amazon was shaped by older human societies, long before anyone in a modern research station thought to call the place remote. A 2023 science study reported a large number of previously undocumented pre-Columbian earthworks and estimated that more than 10,000 may still remain hidden beneath Amazonian forest cover. So the green gaps on a modern map are not proof of emptiness. They are often proof that the map is late. It helps to picture how field access really works, because this is where the romance of exploration usually meets a waterproof bag full of batteries and begins to lose some of its confidence. In much of the Amazon, rivers are the roads, except roads do not normally shrink in drought, widen in flood, bend around whole systems of channels, depend on the mood of seasonal water levels, and require you to accept that a travel schedule is more a hopeful social agreement than a hard promise. A recent World Bank report on infrastructure and bioeconomy in the Amazon states plainly that rivers are the primary mode of transport in the region and are essential for reaching remote areas, especially in the first stage of transport from deep forest harvesting locations. The same report notes that river mobility is limited by long distances, high fuel costs, aging vessels, lack of signalling and navigational aids, and seasonal droughts and falling river levels that increasingly disrupt navigation. This is not just an inconvenience for commerce, it is the same physical system many researchers depend on when they try to reach undersampled field sites with people, food, fuel, instruments, and enough spare parts to survive the part of the trip when something important decides it no longer wishes to function. The difficulty is not merely that travel takes a long time, it is that travel times themselves are unstable. Research on Western Amazonian river transportation found clear seasonal and directional variation in navigation, with accessibility changing between high water, intermediate, and low water seasons, and with upstream and downstream movement behaving differently depending on river type and channel morphology. The same study found that long travel distances and the lack of clearly scheduled transport create real uncertainty for local communities. That uncertainty matters for science as much as it matters for daily life. A site that seems reachable on paper can become awkward, slow, or effectively unavailable if water drops, a route silts up, a boat connection fails, or a return leg takes far longer than planned. In a city, a late train is irritating. In the interior Amazon, a delay can mean spoiled samples, missed weather windows, missed flights, increased costs, and one more argument for choosing the more accessible site next time, even if the less accessible one is exactly where the unanswered question lives. Then comes the awkward reality that even the river system itself is becoming less dependable. A 2024 study in Communications, Earth and Environment examined drought impacts in the Brazilian Amazon and found that drought events routinely disrupt inland water transport and isolate local populations, limiting access to food, fuel, medicine, healthcare, and education. Using records from 90 gauges, the researchers found that the 2005, 2010, and 2016 droughts were especially severe, with over an additional month of low water conditions in affected areas. That is a serious problem for communities, and it's also a serious problem for any scientific program that assumes boats will continue to reach remote settlements and field stations in the ordinary way. A map may still show a river corridor. The river itself may reply, quite reasonably, that it is not in a cooperative mood this season. This is one reason the blank spaces on Amazon maps are so deceptive to outside eyes. From above, everything can look present and available. The river exists. The forest exists. The distance between 2 points can be measured. A route can be drawn. But a line on a map is not the same thing as routine access, and routine access is what scientific knowledge feeds on. Good field science needs return visits. It needs calibration and retrieval. It needs the boring, excellent repetition that turns one exciting expedition into a reliable data set. Yet the very conditions that make parts of the Amazon ecologically valuable also make them stubbornly expensive in time and transport. The current biology study on research gaps makes this painfully clear. Research effort is not spread evenly, according to where knowledge is most needed. It is pulled toward where scientists can actually go, where institutions already exist, and where repeated work is more feasible. That means the green horizon is not blank because no one cares. It is blank because access keeps voting. Roads might seem like the obvious answer, but roads in the Amazon are less a solution than a trade. They can reduce isolation for some communities and improve access to services, yet they are also among the clearest gateways for deforestation, hunting pressure, land grabbing, and broader ecological disruption. A 2020 PNAS study analysed 75 planned road projects totalling 12,000 kilometres in the Amazon region, precisely because road building carries large environmental and social consequences that cannot be treated as a simple good. Research published in 2025 on South American protected areas likewise found that only remote regions, including large portions of the Amazon basin, still exhibit low road presence within protected areas. That combination tells a revealing story. Some blank spaces remain because roads have not yet reached them in full. Those same spaces are often the ones conservationists most worry about opening too quickly. So when a scientist looks at a roadless section of the Amazon, they are not always thinking, how do we get there faster? Sometimes they're also thinking, what exactly do we break by making this easy? There is a slightly cruel irony in all this. The very things that preserve remote forest can also preserve scientific uncertainty. A place with few roads, low human pressure, difficult river access and high logistical cost may remain ecologically intact for longer, but it may also remain lightly sampled. The result is that some of the forest's most important refuges can become data poor even while they remain biologically rich. The 2023 analysis of Amazonian ecological gaps found that undersampled areas overlap hotspots of future climate and deforestation risk. That means scientists can see, in broad outline, where urgent attention is needed, but often cannot fill those regions with the same density of field evidence available from easier, more institutionally connected sites. It is rather like being told that one wing of a vast library is at risk of burning, while also being told that reaching the door requires a week on unstable transport, a complex permit chain, and a budget someone in an office will describe as ambitious before quietly removing half the line items. Even where researchers do have satellites and remote sensing tools, those blank spaces do not vanish. They simply change form. Remote sensing is extraordinary, but it does not turn the Amazon into an open book. NASA has pointed out that understory fires are especially hard to detect because they are small and the dense canopy blocks much of the fire energy from reaching satellites. A 2023 study on tropical forest degradation similarly noted that logging, fire, edge effects, and minor unpaved roads can remain difficult to map because understory disturbances are occluded, vegetation can recover quickly, and conventional optical remote sensing has limits. So a site can be visible at one level and still obscure the details that matter ecologically. The canopy makes the forest look continuous even when the processes below it are fractured, degraded, burning, or changing fast. The blank space is no longer a white patch on an old explorer's chart. It becomes a green patch full of partial signals, where the broad picture arrives before the ground truth does. And then there is money, which is less romantic than rivers and certainly less cinematic than a scientist cutting through vines at dawn. But it has a decisive influence on where knowledge accumulates. Reaching a remote Amazonian site is not just a transport problem. It is a funding problem multiplied by time. Boats need fuel. Aircraft charters, where possible, are expensive. Supplies must be carried farther. Teams must stay longer if the return route is uncertain. Equipment losses hurt more when replacing them takes weeks. The more remote the site, the harder it becomes to justify repeated campaigns, unless a project is unusually well supported. The World Bank's 2025 infrastructure analysis describes deep forest supply chains as constrained by geography and connectivity gaps from the very start, which is equally true if the product being moved is not acai or Brazil nuts, but scientific equipment, samples, or field personnel. Remote science is rarely impossible in the Amazon. It is more often costly enough that a project gradually begins to bend toward the reachable. Another thing those blank spaces hide is scale. To someone not used to Amazonian distances, a map can make field movement seem more straightforward than it is. A river corridor might appear to link settlement, reserve, and forest interior in one continuous route. But travel in the basin is often stepwise and fragile. Small boats feed into larger routes. Goods and people transfer at improvised docks. Weather changes, depth changes, engines fail, schedules blur. The World Bank report notes that the first leg of transport across the Amazon often depends on small boats and canoes moving goods from harvest locations to nearby markets or processing points. That same dependence on small-scale movement is part of what makes scientific logistics so vulnerable. One broken connection early in the chain can ruin a whole expedition. Scientists do not merely need to enter the blank space once. They need a transport system capable of carrying them in, sustaining them there, and bringing them out with data intact. The green horizon becomes blank whenever one of those stages is weak enough to fail. It is also worth saying, quietly but plainly, that blank spaces persist because science is not just about curiosity. It is about institutional reach. Areas near major research facilities are sampled more often for the simple reason that the distance from lab bench to field site is shorter in both time and money. The current biology study explicitly identified proximity to research facilities as a driver of research probability. That has a practical consequence. The distribution of knowledge in the Amazon often reflects the distribution of institutions, airstrips, boat access, long-term stations, and administrative support, not just the distribution of biodiversity or urgency. A forest can be globally important and still be locally neglected because the nearest well-equipped scientific hub is too far away to make repeated work realistic. This is not a flaw in scientific intent. It is what happens when a huge biome meets finite budgets and the tiresome insistence of physical distance. So the blank spaces on the green horizon are not signs of a place untouched by time. They are signs of a place still filtering how knowledge can be gathered. They mark where water levels decide travel time, where roads are absent or politically fraught, where institutions thin out, where budgets fray, where satellites see the top but not always the underneath, and where history remains partly buried under canopy dense enough to hide entire networks of ancient earthworks. There are absences in scientific coverage created by the meeting of terrain, infrastructure, climate, technology, and restraint. The map is not lying exactly. It is simply telling the truth in a language too simple for the forest it is trying to describe, and once you understand that, the next obstacle starts to feel less like a cartographic problem, and more like a bodily one, because distance in the Amazon is not just a matter of how far away a place is, it is a matter of what that distance does to a team, to equipment, to timing, to fatigue, and to the fragile hope that getting there once means you can do it again. That is where the forest stops being a blank on the map and starts becoming something much more physical, much less negotiable, and far harder to argue with. The trouble with distance in the Amazon is that it does not behave like distance in most places people are used to imagining. In ordinary life, distance suggests roads, timetables, signs, junctions, perhaps a service station with disappointing coffee, and a shelf of snacks that looks far more hopeful than it tastes. Even where a place is remote, there is often still a basic logic to getting there. You drive, or fly, or take a train, or complain about the train, which is one of civilization's more reliable rituals. In much of the Amazon, that logic fades quickly. The route is often a river, the schedule is often conditional, the margin for error is often thinner than outsiders expect. And the difference between a place that looks reachable on a map and a place that can actually be studied well is the sort of difference that can swallow entire research budgets without a trace. For many communities across the Amazon, rivers are not a scenic feature running through the landscape, they are the transport system. A recent World Bank report on infrastructure in the Amazon region states plainly that rivers serve as the primary mode of transport and are essential for reaching remote areas, with the first stage of transport often depending on small boats or canoes, moving people and goods from deep forest areas to nearby points of trade or connection. The same report notes that river mobility is constrained by long distances, high fuel costs, old vessels, limited navigational aids, and increasingly severe low-water conditions. That means the basic act of movement across the region is already fragile before a scientist has packed a single battery, sample tube, or waterproof notebook. That dependence on water changes the meaning of remoteness. A site may not be all that far away in straight-line terms, but straight lines are a luxury of maps, not of fieldwork. A river bends, splits, narrows, shallows, floods, and sometimes becomes the sort of route that looks possible only to someone who has not yet tried it, with 12 cases of equipment and a boat engine that has recently begun making sounds associated with regret. Researchers working on transportation in Western Amazonia found clear seasonal and directional variation in river navigation, with travel patterns shifting between high water, intermediate and low water seasons, and with upstream and downstream movement behaving differently depending on river type and channel form. In other words, the answer to how long does it take is often, that depends which month, which direction, which river, and how optimistic you are feeling this morning. Now, if you're trying to visit a friend, that sort of uncertainty is inconvenient. If you're trying to do science, it is a structural problem. Good field research does not just require arriving somewhere once and taking a heroic photograph beside a tree. It requires repeated access. Instruments must be transported in, installed, checked, recalibrated, sometimes repaired, and eventually removed. Samples must come out intact. Teams must arrive with enough food, water treatment, medical supplies, and fuel to survive the possibility that the return trip will not happen when intended. And then, if the study is worth doing properly, they must come back again. That is where distance starts becoming ruthless. Every extra hour is not just an hour, it is fuel, fatigue, spoilage risk, equipment strain, opportunity cost, and one more reason why researchers often concentrate on places that can be reached without wrestling the transport system into submission. There is a revealing clue in a 2023 scientific data paper that introduced a combined river and street transportation dataset for the Amazon. The authors built it precisely because existing transport data did not properly represent the region's reality, noting that transportation to healthcare in most of the Amazon forest is only possible by river routes, and that travel time estimation is limited if rivers are not treated as functional transport networks. That is a strong statement. It means a normal map of movement is not enough, if even access to healthcare must be modelled through river systems rather than roads. Then the same is true for field science. A research team heading into a remote watershed is not entering some exotic exception to ordinary mobility. It is entering the ordinary mobility of the Amazon, which is simply very different from what most institutions are built around. This is why the phrase, "rivers without roads," matters so much. It captures something that people outside the basin often underestimate. Roads do exist in parts of the Amazon, of course, but road coverage is sparse and uneven, and many remote zones remain roadless or weakly connected. A 2025 study on protected areas in South America found that only remote regions, including large portions of the Amazon basin, still show low road presence within protected areas. That may sound encouraging from a conservation standpoint, and in some respects it is. Fewer roads can mean less fragmentation and fewer immediate pressures from expansion. But from the standpoint of research logistics, it means that many of the places scientists most want to understand are the very places where no truck can save them, no quick overland route exists, and no ordinary transport assumption holds for long. There is another layer to this. Road building is not a simple answer, even where it is technically possible. A 2020 PNAS study analysing 75 planned road projects totalling about 12,000 kilometres across the Amazon showed how road expansion is deeply tied to environmental and social consequences. Roads bring access, yes, but they also bring deforestation, land conflict, habitat fragmentation, settlement pressure, and a whole convoy of unintended results that the forest usually receives with very poor grace. So when someone casually proposes that scientists could just build more infrastructure and solve the access problem, they're usually skipping over the inconvenient part where solving one difficulty creates several others, some of them permanent. The Amazon has a way of forcing hard trades instead of tidy solutions. In practical terms, the result is that field teams often travel the way communities travel, by boat, over long stretches, on routes that change with water level and season. The World Health Organization described one vaccine delivery effort to remote indigenous communities in Amazonas by noting that roads are few and medical teams must travel hours by boat to reach remote jungle villages. Doctors Without Borders, writing about work in the Amazon region of Brazil, described rivers, rainforest and distance as major barriers to care. These are health examples, but they illuminate the broader geography perfectly. If something as urgent as healthcare still has to negotiate long boat journeys, changing water conditions and limited infrastructure, then science, which is important but rarely treated as more urgent than medicine, must negotiate the same world with even less operational priority. This is part of what makes distance in the Amazon so unsentimental. It does not care why you are travelling. It does not reward good intentions. It does not grant a research discount because your project has a serious title and a grant application full of noble phrases about biodiversity monitoring. The river asks the same questions of everyone. Is there enough water? Is there enough fuel? Is the route open? Is the weather turning? Does the engine work? Did you pack what you need when the optimistic version of the plan stops working? The forest can be many things, but indulgent is not one of them. Seasonality sharpens all of this. In many parts of the basin, water levels do not merely alter scenery, they reorganize movement. During high water periods, some routes open, and travel may become easier in certain floodplain systems. During low water, channels become narrow, shallow, or impassable, and what was once a straightforward boat journey can turn into delay, detour, hauling, waiting, or cancellation. The Western Amazonia Transport Study found that navigation patterns shift clearly by season and by river type, which means mobility in the region is inherently dynamic rather than fixed. This matters enormously for scientific planning because a site that is accessible in one field season may be awkward or unreachable in another, and long-term research depends on consistency more than drama. One triumphant visit is useful. 10 comparable visits are much better. In recent years, drought has made the transport problem even harsher. A 2024 study in Communications, Earth and Environment found that severe droughts reduce river navigability and isolate communities in the Brazilian Amazon. Using gauge records and community exposure analysis, the authors showed that the 2005, 2010 and 2016 droughts produced especially severe low water conditions, adding more than a month of low river days in affected areas and increasing isolation for riverine settlements. When rivers serve as the main transportation system, low water is not just an environmental detail, it is a direct cut to movement, supply, healthcare, schooling and communication. It is also a direct cut to field science, because any research plan that relies on boat access is only as stable as the river itself, and lately the river has not been especially stable. That same study is especially useful because it clears away a common misunderstanding. People often imagine the Amazon as a place where the problem is too much water, and yes, flood is certainly one of the region's talents. But the transport reality is more complicated. Too much water can alter routes and create hazards, yet too little water can be just as disruptive, stranding boats, cutting communities off, and turning ordinary movement into a slow, costly improvisation. The river is not simply a highway, it is a living system whose navigability changes. That is manageable for communities because communities have experience, local knowledge, and routines built over generations. It is harder for outside research teams trying to impose tidy schedules on a system that views tidy schedules as a curious urban superstition. Scientific coverage reflects this harsh geography very clearly. The 2023 Current Biology study on ecological research, Gaps in the Brazilian Amazon, found that accessibility and proximity to research facilities strongly influence where ecological sampling happens. The authors compiled metadata from 7,694 sites and showed that logistics explain a great deal of research probability across the biome. That finding matters because it strips away the flattering illusion that science always goes first to the most important unanswered question. Often, it goes first to where the boat can go, where the station exists, where transport can be sustained, and where returning next year is still plausible. The unknown accumulates where logistics become punishing. Distance, in that sense, does not merely slow knowledge, it bends it. There is a quiet violence in that bending. It means data are denser near what is reachable and thinner where routes are longer, more expensive or seasonally unreliable. It means some of the least studied places may also be among the places changing most rapidly under climate pressure or land use change. It means a map of scientific effort is partly a map of transport inequality. And it means that when people ask why certain areas of the Amazon remain less understood, part of the answer is brutally simple. Because getting there hurts. It hurts the budget. It hurts the schedule. It hurts the odds of repeat sampling. It hurts every stage of the chain that turns a journey into usable science. One can see this in the smaller details too. Boats can carry a surprising amount, but scientific work is greedy in its own polite way. GPS units, sampling kits, protective cases, solar chargers, ropes, batteries, water filters, medical packs, specimen storage, food for the people carrying food for the people, extra fuel, spare engine parts, communication equipment, waterproofing for the equipment that is supposedly already waterproof, and all the little unglamorous necessities that no one places in the documentary montage because they do not look adventurous enough. Every kilogram matters when the route is long. Every additional day matters when refrigeration is limited and extraction uncertain. And every assumption about resupply becomes dangerous if the nearest help is not down the road, but somewhere beyond a set of river bends and a fuel calculation you would rather not repeat under pressure. Then there is exhaustion, which field reports often discuss more politely than it deserves. Long river travel is physically tiring in ways outsiders rarely calculate. Heat accumulates, humidity accumulates, noise accumulates, sleep becomes thin, gear has to be watched, bodies stiffen, concentration frays. None of that is dramatic, but it matters. A team that arrives after a punishing journey is not in the same condition as a team stepping out of a truck onto a well-marked site. Researchers still have to work once they arrive, and the Amazon has a very specific sense of humour about the idea that arrival should feel like completion. Usually, arrival is when the harder part begins. This is also why distance can be medically unforgiving. In remote Amazonian contexts, the same transport barriers that complicate science complicate evacuation. The studies and reports on healthcare access make this starkly clear. The need for river-based movement means that an injury, infection, allergic reaction, or sudden illness does not occur against a background of quick rescue. It occurs against a background of river time. That reality sits behind every serious field plan, every risk assessment, every decision about whether a site is worth entering at all. The farther a team goes by water, the more every manageable problem starts asking whether it would still be manageable after 6 hours, 12 hours, or a day and a half of difficult transport. For this reason, many of the places that remain undersampled are not remote in a romantic sense. They are remote in an operational sense. Remote enough that repeat work becomes hard to justify. Remote enough that instruments may fail before support arrives. Remote enough that a delayed boat is not a nuisance but a threat to the whole season's plan. Remote enough that funding bodies and project managers begin, however reluctantly, to favour the site that is slightly less revealing and far more reachable. There is no villain in this, unless one insists on naming geography as a villain, which seems unfair because geography is merely doing its job very thoroughly. It is also worth noticing how all this reshapes scientific time. In many environments, a field season can be planned with the confidence that transport is a means to the research. In the Amazon, transport often becomes part of the research problem itself. Travel windows shape sampling windows. River level shapes route choice. Engine reliability shapes how much gear can safely be carried. Drought years and flood years shift to not only ecology, but access to ecology. A project that looks straightforward in the abstract becomes an exercise in adaptive logistics. This is one reason local expertise is so essential. Boat pilots, guides, field assistants, residents, and indigenous communities often know the transport reality far better than any institution looking at regional maps from afar. Without that knowledge, distance becomes even crueler, because then it is not just long, it is full of preventable mistakes. By now, the point becomes difficult to ignore. The Amazon is not only a forest, it is a transport challenge spread across a forest. Its rivers connect and isolate at the same time. They are lifelines, roads, boundaries, delays, routes, and hazards all at once. They make movement possible, but never easy in the way outsiders usually mean by easy. They allow access, but often on terms set by season, water, cost, and endurance rather than by institutional desire. So when scientists avoid certain areas, or reach them only rarely, or sample around them instead of through them, distance is often sitting at the centre of the explanation with folded arms and no intention of apologising, and yet even that does not exhaust the problem. Because after the boat, after the schedule, after the fuel, after the long river and the shifting channel and the tired arrival, there is still the place itself. There is still the air, heavy and persistent. There is still the ground, soft when you want it firm and hostile when you want it simple. There is still the feeling that the landscape has only allowed you through the first door and has several more waiting just ahead. By the time a research team has dealt with the river, the fuel, the route, the permissions, and the long arithmetic of getting people and equipment into a remote site, it would be nice if the forest itself offered a small gesture of cooperation. A gentle breeze, perhaps, a patch of firm ground, a stretch of air that does not feel as though someone has draped a warm, wet blanket over the face of the day. The Amazon, with its usual commitment to not becoming anyone's simple workplace, tends not to provide that gesture. One of the reasons certain areas remain lightly studied is not only that they are far away, but that once you arrive, the environment keeps taxing the body, the gear, and the timeline. The challenge is physical in a blunt, unsentimental way. Humidity adds substantially to heat stress. Travel in tropical forests can be slow and exhausting. Disorientation is easy, and continuous dampness makes it difficult to keep camps and equipment in good condition. Those are not dramatic embellishments. They're exactly the sort of practical problems expedition medicine treats as ordinary in hot, humid tropical forests. The first part of the problem is the air itself. The Amazon is not hot in the same way as a dry desert or a bright open savanna. In many parts of the basin, the climate is warm year-round, with annual rainfall commonly in the range of roughly 1,500 to 3,000 millimetres and average relative humidity around 88%. Some overviews place typical temperatures around 24 to 27 degrees Celsius and relative humidity at roughly 80 to 94% through the year. That combination matters because humidity changes how heat feels and how the body gets rid of it. Sweat only cools effectively when it can evaporate. In very humid air, that process works less well, so exertion becomes heavier, recovery becomes slower, and the difference between manageable discomfort and real heat strain narrows more quickly than many outsiders expect. There is a useful correction to make here, because the popular imagination often gets the forest interior slightly wrong. Dense canopy can buffer microclimate. A 2025 study in agricultural and forest meteorology found that Amazonian understory temperatures remained consistently lower than the surrounding macroclimate, and that this buffering was generally stronger in the rainy season, especially where precipitation, canopy height and leaf area were greater. So the forest understory is not simply an oven in the most direct sense. The canopy can soften temperature extremes, but cooler than outside the forest is not the same thing as comfortable. The same work also noted that these microclimates are nuanced and understudied, and expedition medicine guidance remains very clear that humidity itself adds significantly to physiological heat stress. A researcher walking, carrying gear, climbing over roots, cutting through dense growth, or working for hours without much airflow can still end a day wrung out by the simple effort of moving through wet heat. The forest does not have to be the hottest place on paper to be deeply tiring in practice. This matters more than it may first appear, because field science is not gentle exercise. It involves lifting, hauling, wading, packing, unpacking, climbing, stooping, balancing, and doing all of it while trying not to damage expensive equipment or your own knees. A person can be very fit and still discover that tropical humidity is a separate argument entirely. The Oxford Handbook chapter on hot, humid tropical environments notes that these conditions demand more acclimatization than hot, dry deserts, and that travel can be physically exhausting. That is a sobering sentence if one pauses over it. Deserts, at least in the imagination, usually get top billing for punishing heat. Yet tropical forests earn their place on the same warning page because the body struggles differently there. Heat does not always arrive as a blaze. Sometimes it arrives as a slow tax that never quite lifts. And that kind of tax is exactly the sort that wears down attention, pacing, hydration discipline, and judgment. Then there is dampness, which sounds harmless when written calmly, almost domestic, as though one is discussing a troublesome bathroom corner rather than an entire living system. Continuous dampness in the Amazon is not merely annoying, it is operational. The expedition medicine guidance states directly that it makes it hard to keep camp and equipment in good condition. Anyone who has done fieldwork in wet conditions will recognise the chain reaction. Clothing never quite dries, socks become a small philosophical crisis, paper curls, labels loosen, metal corrodes, electronics fog, fail, or need constant protection. Storage becomes a battle against mould, leaks, rot, and the general tendency of water to appear where it was not invited. Even when gear survives, it takes more time and attention to keep it usable, and every minute spent rescuing batteries, drying cases, or repacking wet supplies is a minute not spent on observation or measurement. In a remote research site, those losses accumulate quietly but relentlessly. The body pays for the dampness as well. The same Oxford source flags wound management as vital in tropical forests and lists immersion foot, tropical ulcers, skin infestations and leeches among the additional hazards of working in these environments. That is the sort of sentence that tends to take some of the glamour out of the word expedition very efficiently. It also explains why serious researchers tend to describe the forest with more respect than romance. A small cut on an ordinary walk can be ignored. A small cut in a wet tropical field site becomes a maintenance issue. Feet that stay wet too long stop being merely uncomfortable. Skin softens, breaks down, and becomes more vulnerable to infection. Camps and field teams must manage not only science, but hygiene, drainage, drying, wound care, and routine prevention. The air does not simply feel heavy. it turns neglect into consequences. The ground is no easier. One of the common misunderstandings about the Amazon is that a rainforest floor must be soft, rich, and forgiving because the vegetation above it looks so abundant. In reality, much of Amazonian upland, or terra firme, forest sits on highly weathered oxysols and altisols, soils characterized by high acidity and low nutrient concentrations. A 2021 Nature Communications paper on Amazonian dark earths states this plainly, and notes that native plant species rely on adaptations such as nutrient uptake from litter to maintain productivity in what are otherwise very poor soils. Another 2024 study on dissolved organic nutrients in Amazon rainforest ecosystems likewise describes the soils as nutrient poor and emphasizes how important efficient nutrient recycling is to sustaining productivity. The forest looks lavish, but much of that productivity depends on tight recycling, rather than deep reserves of easy fertility in the ground itself. That ecological fact matters for fieldwork, because it helps explain why the ground is often not the stable, generous surface outsiders imagine. Nutrients are concentrated in rapid cycling near the surface rather than in some endlessly rich store waiting underneath. The forest is productive partly because the system is efficient, not because the soil is simple. Even without turning that into a full soil lecture, the practical lesson is clear. Abundance above ground does not mean ease underfoot. The Amazon can look full and still be physically awkward, acidic, leached, seasonally saturated, and difficult to work on. Exceptions exist, of course. Amazonian dark earths are unusually fertile, and some floodplain soils can be naturally richer, especially along major rivers. But the very existence of those famous fertile exceptions has fascinated scientists precisely because they stand out against the broader background of highly weathered, nutrient-poor tropical upland soils. Now add water back into the picture, because the Amazon rarely allows anyone to discuss soil for long without introducing a flood. A great deal of the basin's ecological variation is driven by hydrology, and in some central Amazonian floodplain forests, the conditions are extreme. A 2024 paper in Nature Ecology and Evolution reports that parts of central Amazonia experience up to 300 flood days annually, and flood amplitudes of 9 to 12 metres. That is not seasonal inconvenience in the everyday sense. That is a landscape spending much of the year profoundly rearranged by water. For researchers, it means that ground is sometimes temporary, sometimes soft, sometimes submerged, and sometimes absent altogether as a reliable surface for movement, camp placement, or instrument installation. A field site in one season can become a very different working environment in another. This is one reason the forest often seems to fight back without doing anything theatrical. It does not need dramatic predators at every step to make scientific work hard. It only needs to keep changing the conditions of movement. A route that was passable becomes waterlogged. A patch of usable ground becomes mud or shallow standing water. A camp location that looked fine at first becomes a long argument with drainage. A transect that was annoying in the dry period becomes nearly comic in the wet one, except the humour fades after the third hour of trying to keep sample bags clean and yourself upright. Scientists working in the Amazon do not just study ecological seasonality. They work inside it, and that means the ground itself can switch personalities on them with very little interest in their schedule. Even when the forest floor is not flooded, movement can still be slow and disorienting. The Expedition Medicine Handbook makes that explicit, noting both slow travel and ease of disorientation in tropical forests. This is not merely about getting lost in a cinematic sense. It is about the fact that dense vegetation reduces sightlines. The terrain can be irregular, and progress is rarely as simple as walk from here to there. Every detour around water, fallen timber, dense undergrowth, or unstable footing costs time and energy. In open terrain, distance can often be judged by sight. In dense rainforest, the body learns distance by accumulation. A short distance on the map may become a long hour of stepping, ducking, climbing, balancing and checking bearings, often enough to keep small navigational errors from becoming expensive ones. That constant friction shapes the kind of science that can realistically be done. Large instruments become harder to move. Delicate instruments become harder to protect. Repeated measurements become more costly if every return to the same point requires another round of exhausting, wet, careful progress. Sites that are theoretically near each other can behave as though they belong to different worlds if one lies on better drained terrain and another sits in a low, flood-prone, perpetually soggy piece of forest. This is one reason access is never just about the boat trip. The boat merely delivers a team to the next stage of resistance. Storms add another layer. A 2025 review in Global Change Biology argues that convective storms are an important driver of change in tropical forests, and notes that storm-caused disturbances can sharply increase tree mortality in small-scale clusters, with very high biomass mortality in some disturbance patches. The authors also show that storm activity is widespread across the Amazon and not neatly limited to the places of highest drought stress. That matters for anyone on the ground because severe weather is not only a background climate statistic, it can suddenly rearrange a site, damage access routes, bring down timber, and turn an already difficult environment into one where overhead hazards become part of daily judgment. The Oxford guidance mentions falling timber for a reason. In a forest built from very large trees and periodic violent weather, gravity remains an old and dependable hazard. Another subtle problem is that the forest's apparent abundance can mislead inexperienced visitors into underestimating the cost of basic maintenance. In drier environments, a camp can remain a camp with modest effort. In the Amazon, campcraft is a discipline. The Oxford source emphasises that living comfortably in the jungle requires knowledge, sound campcraft, and careful management of water supplies and latrines. Comfortably is doing generous work there. What it really means is that even routine living arrangements require constant attention. Waste has to be managed safely. Drinking water has to be protected or treated. Sleeping arrangements have to be kept as dry as possible. Food has to be stored sensibly. Wet gear has to be rotated, cleaned, or dried when drying is possible. A research project can be scientifically excellent and still fail operationally if the camp itself becomes a source of illness, fatigue, or equipment loss. All of this explains why some Amazon field science becomes highly local and highly dependent on experience. The forest is not uniformly punishing in exactly the same way everywhere. Microclimate varies across the basin, and the 2025 microclimate study found differences in buffering capacity associated with precipitation, canopy structure, and terrain slope. That means conditions can shift from one site to another in ways that matter both ecologically and physically. Some forests buffer temperature better. Some slopes reduce that buffering. Some sites stay wetter longer. Some flood more severely. Some have better campground nearby. Some never really do. Outsiders often imagine the Amazon as one giant environment with one giant set of rules. Scientists know better because the body notices quickly when one patch of forest behaves differently from the last. It is also worth noticing that the very traits that make the Amazon globally important, its high rainfall, dense canopy, intense nutrient cycling, and giant fluvial system, are the same traits that complicate the ordinary mechanics of field research. High rainfall helps sustain the forest, but it also keeps everything wet. Dense canopy shapes the understory climate, but it also holds humidity and blocks light, drying, and easy observation. Rapid nutrient cycling helps maintain productivity on poor soils, but it does not provide the kind of straightforward ground conditions outsiders associate with fertile land. Exceptional flood dynamics generate unique habitats, but they also mean some places spend much of the year half drowned or fully flooded. The forest's ecological success and the researcher's practical success are not the same thing. Often, They are opposite sides of the same condition. This is why serious scientists often sound less enchanted and more methodical when they describe remote Amazon work. They are not unimpressed by the forest. Quite the opposite. They're impressed in the specific way that makes a person double-check their boots, waterproofing, route notes, and medical kit. The air exhausts steadily. The dampness corrupts gear patiently. The ground changes terms without warning. The floodplain does not care that you intended to finish before lunch. The storm does not care that your data logger is expensive. The forest floor, for all its leaves and shade, is not a kindly carpet spread out for inquiry. It is a working surface that keeps reminding the visitor that living systems are not designed for human convenience. And after a while, that constant physical negotiation changes what avoidance means. It stops sounding like fear in the ordinary sense and starts sounding like cost, exposure, and attrition. Some places are avoided not because no one is brave enough, but because the air and ground together make extended work too punishing, too risky, or too expensive in human effort for the likely return. Science is built on persistence, and persistence becomes harder in environments that tax every hour of being present. A region can be scientifically important and still remain lightly sampled if just staying functional there consumes too much of the expedition's strength. Then, of course, there is the smaller problem, or rather, the many smaller problems, because once a team has accepted the humidity, the soaked boots, the acid soils, the flood pulse, the storm risk, the camp hygiene, and the endless maintenance required simply to remain competent and uninfected, the forest still has one more habit of making itself known. It does not only resist through heat, water, and ground, it also resists through the creatures that bite, burrow, sting, infect, and wait quietly for a lapse in discipline. And that is where the discomfort of the environment begins to share the stage with something sharper. After the river, after the heat, after the wet ground and the long march of logistics, the Amazon still has one more way of wearing people down. It does not rely only on distance or weather. It also relies on creatures small enough to be missed, quiet enough to be ignored, or common enough to stop seeming dramatic until the symptoms begin. This is one reason scientists can sound so careful when they talk about remote forest work. The danger is not only the obvious sort, not only the storybook version with a sudden strike from something large and theatrical. Much of the real risk comes from bites, stings, and infections that start small, then expand slowly through hours, days, or weeks. The World Health Organization notes that neglected tropical diseases are often tied to environmental conditions, frequently vector-borne, and associated with complex life cycles that make public health control difficult. In tropical forests, that complexity is not theoretical. It is part of the workday. Snakebite is the clearest example of venom turning remoteness into danger. WHO classifies snakebite and venoming as a neglected public health issue, and notes that most cases occur in tropical and subtropical countries, including Latin America. That already tells you something important. A snakebite is not simply an unlucky encounter with wildlife. In many rural, tropical settings, it is a known medical problem shaped by where people walk, work, and how fast they can reach treatment. In the Amazon, that second part is often the cruelest. Venom does not wait politely for the boat's schedule. Older epidemiological work from Acre in northwestern Brazil found that among forest-dwelling Amazonian indigenous communities and rubber tappers, snakebite was an important cause of morbidity and death, with most bites occurring in the jungle or on jungle trails, often while people were working or walking, and most often on the feet. A later case control study summarised in the same article preview reported that the Brazilian Amazon has the highest incidence of snakebite envenomings in Brazil, and that delays of more than 6 hours before medical assistance were associated with greater severity and greater risk of death. That is the part outsiders often miss. The bite is only the beginning. Distance and delay decide the rest. a 2023 PLOS Neglected Tropical Diseases study from 2 indigenous health districts in the western Brazilian Amazon makes the access problem painfully concrete. Among the 187 interviewed snakebite victims in that study, lack of transportation and lack of financial resources were among the main reasons people did not access hospital care, and 4 deaths were reported. The study also found that some villages had only indigenous medicine available locally. That is not a criticism of local knowledge. It is a statement about what happens when modern treatment is far away. In a remote forest setting, the interval between injury and anti-venom is not measured by how quickly an ambulance can arrive. It is measured by rivers, fuel, weather, and whether there is any transport at all. This is why venom in the Amazon often kills slowly rather than dramatically. A bite may begin with pain and swelling, but the real damage is often done by time. Tissue injury worsens, bleeding or systemic effects progress. Infection can follow, the victim grows weaker while the route to care remains long. Even when people survive, the cost can be permanent in function, mobility, and work. Snakebite sits inside WHO's broader neglected tropical disease framework precisely because it is not only a wildlife problem, it is a problem of marginalisation, distance, and delayed care. For researchers, this matters because working far from medical support means every step through leaf litter, every night walk to a latrine, and every careless hand placed near roots or wood becomes a medical calculation, not just an adventurous moment. Yet venom is only one part of the forest's smaller warfare. Mosquitoes are usually more important to the daily risk picture than anything with fangs. WHO describes malaria as a life-threatening disease caused by parasites and spread to humans by certain mosquitoes, adding that it is preventable and curable. That sentence is reassuring in the abstract and much less reassuring when placed inside a humid river basin full of breeding habitat, outdoor work, and communities that may still be hours from diagnosis. Preventable and curable is true. It does not mean easy to avoid in the field. WHO's own reporting from Loreto in the Peruvian Amazon shows how neatly the environment can serve the parasite. In that region, where rivers function as highways, humidity exceeds 80%. Heavy rains and flooding are common, and rain-fed swamps and slow-flowing waters create ideal mosquito breeding conditions. WHO reported that Loreto's malaria hotspots account for 96% of Peru's malaria burden, and that Anopheles darlingii was the most abundant mosquito species in the study sites described. That is a useful reminder that the Amazon is not just a forest full of mosquitoes in some vague sense. In certain places, the ecology lines up so well for transmission that a human being entering the system is simply another meal in a landscape designed for the vector's success. The same WHO feature also reported that bed nets, although widely used, did not provide adequate protection in those study communities because most transmission occurred outdoors. That detail matters because it disrupts a comfortable assumption. People often imagine tropical disease prevention as a nighttime problem solved by tucking oneself under treated mesh and congratulating science. In some Amazonian settings, the risk remains outside the hut, outside the sleeping hours, and outside the simple mental picture of danger arriving only after dark. For scientists spending long hours walking transects, working on riverbanks, setting traps, or moving between camps and sampling sites, exposure is woven into the work itself. Yellow fever adds another layer, and it is especially sobering because unlike malaria, it has a vaccine that works extremely well, meaning many severe infections are preventable if people are properly vaccinated before they enter risk zones. WHO states that yellow fever is a mosquito-borne viral disease transmitted by Aedes, Haemogogus, and Sebethes mosquitoes, which breed in domestic, forest, and semi-domestic environments. WHO also notes that a single vaccine dose provides lifelong protection for most people. But the disease remains serious. About 15% of infected people go on to develop severe illness, and around half of those severe cases die within 7 to 10 days. Forest scientists know this, which is why yellow fever vaccination is not a bureaucratic footnote for Amazon work. It is basic preparation. Yellow fever is also a useful example of how the forest ignores lazy mental categories. WHO notes that the mosquitoes transmitting yellow fever bite during the daytime, which means bed nets are less effective as a main protection measure. The virus persists in sylvatic cycles involving forest mosquitoes and non-human primates, and humans are exposed when work or travel takes them into those environments. That is exactly the kind of risk profile that troubles field research. A person can be careful, competent and physically prepared, yet still be placed inside a daytime transmission system that does not care how advanced their GPS unit is. The first line of defense is not bravery. It is vaccination, protective clothing, repellents, and refusing to treat mosquito exposure as a trivial annoyance. Then come the sandflies, which are very easy to underestimate because their bite does not announce itself with much drama. Leishmaniasis, according to WHO, is transmitted by infected female phlebotomine sandflies. The cutaneous form is the most common and causes skin lesions, often ulcers, on exposed parts of the body, while mucocutaneous disease can destroy tissues of the nose, mouth and throat. WHO further notes that over 90% of mucocutaneous cases occur in Bolivia, Brazil, Ethiopia and Peru. This is exactly the kind of illness that fits the phrase "kill slowly," not always because it kills outright, but because it can scar, deform, disable and reappear in the story of a person long after a tiny bite seemed unimportant. PAHO's regional data show that this is not a niche curiosity. In the Americas, cutaneous leishmaniasis is the main form of the disease. The epidemiology is complex, multiple leishmania species circulate, and wild animals serve as sylvatic reservoirs. PAHO reports an annual average of 38,400 cutaneous and mucosal cases in the region over the last 5 years, with 34,954 cutaneous cases reported in 2023. It also notes that 21% of those 2023 cases were in border areas. Those numbers matter because they remind us that the risk is broad, ecologically messy, and not confined to one neat pocket of forest. A scientist in the Amazon is not only avoiding one famous disease, they are entering an environment where several vector systems overlap and where the bite you barely noticed can become the lesion you are still treating months later. CDC's travel medicine guidance adds an especially grim detail for South and Central America. Some Leishmania species in the Viania group can spread from the skin to mucosal surfaces. A mucosal disease may emerge years after the original skin lesion has healed. In advanced cases, CDC notes that ulcerative destruction can affect the mouth, nose, larynx, and pharynx. This is what makes the small threats of the Amazon so unsettling. They do not always act like the dangers people have rehearsed in their minds. Sometimes the forest leaves a delayed invoice. The bite happens now. The worst damage arrives much later. Chagas disease in the Amazon is another case where the danger has become more complicated than a simple insect bite. CDC reported a 2017 outbreak of acute Chagas disease in the Brazilian Amazon, in which patient blood and assay juice samples both contain Trypanosoma cruzi, indicating oral transmission. The same CDC report notes that increasing outbreaks of acute Chagas disease have drawn the attention of public health authorities, and that the disease is regarded as emerging in the Amazon, with many outbreaks linked not to classic vector contact alone but to contaminated local fruit juices. That should make any outside observer very modest very quickly. Even the old confident distinction between the insect risks and the food risks begins to blur in tropical field settings. That outbreak report is revealing for another reason. One of the patients first presented in Manaus with an acute febrile syndrome, and a routine thick smear was negative for Plasmodium but positive for Trypanosoma cruzi. In plain terms, the symptoms could initially sit inside the same broad, worrying territory as other tropical fevers. This is another way the small things kill slowly. They do not always identify themselves cleanly at the start. They can arrive as fever, malaise, headache, weakness, a sense that something is wrong but not yet legible. In the field, that ambiguity is dangerous. It forces teams to think not only about prevention, but about what happens when a person becomes ill in a place where diagnosis is delayed by transport and symptoms overlap with several serious possibilities. All of this sits inside a larger pattern that WHO describes very clearly. Neglected tropical diseases are associated with devastating health, social and economic consequences, affect more than 1 billion people globally, and are often difficult to control because their epidemiology is tied to environmental conditions, vectors, reservoirs, and complex life cycles. The Amazon concentrates many of those ingredients in one setting. It is humid, biodiverse, riverbound, and full of animal reservoirs, vector habitats, and human populations living or working far from rapid care. The forest does not merely contain disease. It contains the conditions that make disease harder to prevent, harder to diagnose, and harder to treat quickly. This is why experienced field scientists do not talk about insect bites as if they were a cosmetic nuisance. In a temperate city, a bite is usually an annoyance. In remote Amazon work, a bite can be an exposure event. It may be nothing. It may be the start of fever. It may be the lesion that scars. It may be the swelling that becomes infected because boots stayed wet and skin broke down. It may be the event that forces evacuation, halts a survey, or ends a season's work. The danger lies not only in lethality, but in attrition. Small hazards remove time, strength, focus, labour, and margins of safety until a team that looked capable on paper becomes medically fragile in practice. It also changes what preparedness means. In ordinary adventure stories, courage is the main currency. In real Amazon fieldwork, prophylaxis, vaccination, wound care, repellents, clothing discipline, food hygiene, local knowledge, evacuation planning, and the ability to recognise early symptoms are worth far more than swagger. Malaria is preventable and curable. Yellow fever is vaccine preventable. Leishmaniasis depends heavily on vector avoidance and diagnosis, and snakebite outcomes are strongly shaped by speed of treatment and access to care. The scientific instrument is important, certainly, but the body carrying it must remain functional first, and the Amazon is very good at testing that principle. Another reason these risks matter so much is that they scale badly with remoteness. A yellow fever shot can be taken before departure, yes, but a fever in the field still has to be interpreted. Anti-malarials and repellents help, but no prevention system is perfect, especially where exposure is prolonged and much of it occurs outdoors. A sandfly bite can be almost forgettable when it happens. A snake bite can remain survivable if care is quick, then become much more dangerous if the route to treatment is long. In each case, the forest is not relying on one spectacular attack. It is relying on the weakness of the chain between exposure and response. That is the same chain distance and weather have already stretched thin, so when scientists avoid certain areas of the Amazon or enter them only with heavy medical planning and a sober respect for what looks like just insects, this is part of the reason. The forest is full of hazards that do not necessarily stop you at once. They slow you, infect you, scar you, weaken you, complicate your diagnosis, and turn remoteness into a medical multiplier. They do not need to be large to be effective. A day-biting mosquito, a sandfly, a contaminated drink, a hidden snake near a riverbank, each of them can turn a field season into a medical story instead of a scientific one, which is perhaps why modern science keeps trying to keep some of its distance. If every additional body in the forest is another body that can be bitten, stung, infected, or delayed on the way to treatment, then it makes sense that researchers increasingly lean on drones, remote sensing, acoustic monitoring, automated sensors, and every other tool that promises knowledge without so much skin in the game. The difficulty, as we are about to see, is that the Amazon has a very particular talent for frustrating those tools as well. It is tempting to think that the Amazon's old problem has been solved by new machines. After all, the modern scientific toolkit is impressive enough to make previous generations look as though they were entering the forest armed with little more than courage, notebooks, and a deeply unreasonable faith in canvas hats. We now have satellites that watch the Earth continuously, aircraft carrying lasers, drones with thermal cameras, sensors that record sound for weeks, machine learning systems that sort images faster than any graduate student ever could, and genetic methods that can detect species from traces left in water, soil, or rain. From a distance, it can seem as though the canopy should have surrendered by now. The difficulty is that these tools do not fail because they are useless. They fail because the forest is not a simple target. It is layered, wet, cloudy, noisy, moving, and in many places still hard to reach even when the hardware is excellent. The result is not ignorance exactly, it is partial vision. The Amazon is now studied by some of the best technology humans have built, and it still has the irritating habit of remaining only partly cooperative. Take ordinary optical satellites, the kind many people imagine as all-seeing eyes in the sky. They are invaluable, and yet in the tropics they are often obstructed by the most ordinary feature of a rainforest climate: clouds. A Nature Communications paper on Amazon canopy seasonality noted that optical remote sensing in tropical regions is very often obstructed by clouds, that the Amazon receives heavy precipitation with cloud obscuration throughout the year, and that this lack of sufficient clear sky observations has contributed to inconsistent conclusions across studies using the same broad class of satellite data. This is one of those quietly important scientific problems. It is not that the instruments are broken, it is that a forest covered by cloud for much of the year does not offer regular, clean views to a sensor that relies on seeing through the atmosphere in the ordinary optical way. One study says the forest is greening, another says it is not, and somewhere in the middle a large white mass of cloud is behaving as though it has been personally offended by the whole discussion. Clouds are only the first curtain. The canopy itself is the second. Even when a satellite can see the forest from above, what it often sees best is the top surface of a very thick living structure. That is useful for some questions. It is much less useful for others. A 2025 review of remote sensing for forest carbon estimation summarized a basic limitation of optical data very neatly. Optical images are vulnerable to cloud interference and mainly provide horizontal information about the forest rather than true vertical structure. That means they can tell you a great deal about where vegetation is, how reflective it is, how it changes over time, and how land cover shifts. They are much less able, by themselves, to tell you what is happening below the top layer in a forest, where lower strata matter enormously. If your question is about understory degradation, fine-scale structural change, or what is happening beneath dense crowns, the simple overhead view becomes less like an answer, and more like the first page of a much longer report. This becomes painfully clear with fire. NASA Earth data reported in 2024 that low-intensity Amazon understory fires are very hard to spot from satellites and are often misclassified, with one researcher stating that the dense canopy intercepts the fire energy and blocks it from reaching the satellite. That means a forest can be burning underneath while the treetops above keep enough of their shape and cover to hide the event from common thermal detection methods. So when people say, "But surely satellites would notice," the answer is, sometimes they do, and sometimes the fire is small, the canopy is thick, and the satellite is essentially being lied to by leaves. The same NASA reporting notes that the commonly used VIIRS and MODIS fire detection systems are generally excellent at global wildfire detection, but not ideal for detecting these Amazon hotspots. Modern tools are powerful. The canopy still edits what they get to know. Radar helps with one major problem because radar can see through clouds in ways optical sensors cannot. NASA's Earth Observatory made that point years ago when describing efforts to map flooded Amazon forests. explaining that rain clouds hid the forest from optical satellite view and drove researchers toward radar instead. A recent review likewise notes that SAR is less susceptible to weather and cloud cover and can provide structural information that optical data miss. But radar is not magic either. The same review points out that SAR processing is complex, that sensitivity to vegetation type can be limited, and that terrain effects can distort radar echoes in complicated landscapes. In other words, radar solves one problem and introduces another set of technical chores, interpretive uncertainties and processing burdens. The forest is perfectly happy to allow this exchange. LiDAR is often described as the answer to the canopy problem, and in some ways it genuinely is one of the best answers science has. LiDAR can recover three-dimensional information about vegetation structure, including canopy layering, height profiles, and structural variation that ordinary optical imagery cannot provide. NASA and other researchers have used airborne and spaceborne LiDAR to map canopy turnover, storm damage, forest structure, and biomass in ways that would have been impossible from ordinary imagery alone. Yet even here, the victory is partial. A NASA-linked study on Amazon canopy roughness stated directly that airborne LiDAR is limited by cost and practical considerations to specific research sites and is not available across the whole landscape. Another review in 2025 added that LiDAR coverage is relatively limited for large-scale, rapid monitoring, and that even spaceborne LiDAR products can remain insufficient in spatial resolution for some high-precision applications. So yes, the laser can tell you wonderful things. It simply cannot be everywhere at once, which is a recurring theme in Amazon science, and, come to think of it, in life. Spaceborne LiDAR has its own particular limits. NASA training material for Getty, one of the most important recent forest structure missions, states plainly that GEDI does not provide wall-to-wall coverage like a gridded satellite image. Its footprints are about 25 meters in diameter, sampled roughly every 60 meters along track, with tracks about 600 meters apart, and the system is sampling-based rather than continuous. The same material notes that the amount of observations tends to decrease toward the equator, that footprint-level data can be susceptible to geolocation error and inconsistent sample density, and that gridded products may overgeneralize or overlook finer disturbances. NASA also notes that in very dense tropical forests or complex terrain, more shots may be filtered out because ground detection becomes uncertain. That is a remarkably honest description of a very advanced instrument. It doesn't say, "We have solved the canopy." It says more or less, "We have built something extraordinary, and it still needs quality filtering, fusion with other data sets, and caution in dense tropical forests." Then there are drones, which are often introduced in popular writing as though they have finally given scientists the nimble, affordable, everywhere-at-once eyes they always wanted. Drones are genuinely useful. They can fill gaps between field plots and satellites, carry cameras or LiDAR, and access places that are awkward for humans on foot. But the under-canopy environment is a poor place for simple drone fantasies. A 2025 review of autonomous UAV navigation under canopy described dense obstacles, GNSS interference, varying lighting, uneven information, and limited flight space as core challenges, adding that autonomous under-canopy navigation remains in the early stages of development. The same paper notes that when GNSS signals are blocked and lighting is poor, positioning and planning capabilities are significantly diminished. Another study on under-canopy photogrammetry described the work as taking place in challenging forest and terrain conditions. This is the forest saying, once again, that a drone is still a visitor, and visitors must deal with branches, clutter, shadows, narrow corridors, and the basic inconvenience of flying a machine through what is, from the machine's perspective, a three-dimensional obstacle course made of wood. Even above the canopy, drones carry mundane limitations that become serious in remote rainforests. Flight times are constrained by battery life. One scientific report study on airborne optical sectioning noted that drone battery life can be limited to roughly 15 to 30 minutes, depending on weight and wind conditions, restricting the synthetic aperture size and therefore the data that can be collected in one flight. Broader reviews of drones in environmental mapping likewise note that short battery life, weather sensitivity, and operational complexity constrain how much area can be covered. In a nearby, accessible research site, a short flight means swapping batteries and trying again. In a remote Amazonian field camp, it means every battery charged, carried, dried, protected, and rationed becomes part of the data itself. If one imagines drones as a clean escape from hard field work, the Amazon usually answers by adding humidity, branches, and logistics until the pilot remembers they are still in the Amazon. GPS and GNSS introduce another quiet disappointment. People outside field science often assume that once you have satellites overhead, position itself becomes a solved problem. Under dense forest cover, it is less solved than negotiated. Studies on GNSS under tree canopy show that canopy affects signal quality through obstruction and multipath, and that results can vary substantially depending on equipment quality, occupation time, and processing. A 2023 open access study found that a low-cost smartphone under vegetation canopy had horizontal errors of around 1.5 meters, while a better standalone receiver with longer static observations could still achieve much better performance. A recent review of under canopy UAV navigation goes further, describing GNSS signals as blocked or interfered with beneath the canopy. This does not mean location is impossible. It means that easy, real-time, high-confidence positioning is less easy than many modern users expect, especially for small low-cost devices or moving platforms. The forest does not completely remove the signal. It complicates it, weakens it, reflects it, and makes the path from satellite to researcher just messy enough to matter. Wildlife tools also behave less like magic than brochures suggest. Camera traps are brilliant, and they have transformed tropical ecology, but they do not observe animals in a neutral way. A review of wildlife monitoring in tropical forests notes that dense vegetation, cryptic species, low abundances, limited visibility, and variable detection probability make monitoring especially challenging. Camera placement matters, and sometimes it matters a great deal. A PLOS One study on camera placement found that small-scale habitat features such as game trails and logs can dramatically alter capture rates and detection probabilities, with some species showing much higher detectability at feature-based locations. That means a camera trap is not simply watching the forest. It is watching one tiny corridor of behavior shaped by placement, visibility, trail use, and vegetation structure. A jaguar on a trail is easier to detect than a shy creature moving 3 meters away through dense understory and never once agreeing to behave statistically. Passive acoustic monitoring is often proposed as a gentler solution because microphones can stay in place and let the forest announce itself. That works beautifully for many questions. It also comes with caveats. The same tropical monitoring review describes trade-offs across human observation, cameras, and passive acoustic sensors rather than naming any one method as universally superior. WWF's acoustic monitoring guidelines add that detection distances depend on call amplitude and frequency, but also on temperature, humidity, ambient noise, and habitat structure such as vegetation. High frequencies attenuate more quickly, clutter reduces detectability, and acoustic indices can be sensitive to non-biotic noise. In plain language, a recorder may hear some species very well, some badly, and some not at all, and the local forest structure partly decides which is which. The Amazon is full of sound, but sound is not the same as equal detectability. A loud bird in an open pocket of forest is not recorded on the same terms as a faint insect behind wet vegetation and a sheet of rain. Environmental DNA sounds even more modern, and in many ways it is. A 2025 Science Advances paper showed that rainwash, eDNA can reveal biodiversity hidden in tropical forest canopies and described it as a promising, low-cost, non-invasive tool for inaccessible canopy environments. That is exactly the sort of innovation people mean when they say science has new eyes. Yet the same paper also says what careful scientists always say. It is promising, it needs comparison with other substrates, and it helps clarify strengths and optimal applications rather than ending the conversation. eDNA can tell us that biological traces are present. It still needs interpretation, validation, and often supporting data. It is not a replacement for every other method. It is another piece of a toolkit that works best when paired with other pieces, local knowledge and restraint. Even fixed sensor networks, which seem ideal for avoiding repeated human entry, discover quickly that the rainforest is a poor host for fragile instruments. A 2023 paper on sensor networks in a tropical rainforest described challenges including constant high humidity, heavy rainfall, flooding, small invertebrates entering tiny openings, rust, microbial growth, and the need to seal housings carefully to prevent insect colonization. The authors wrote that numerous modifications were required simply to operate their sensor arrays successfully under those conditions. That is a useful fact because it removes one more modern illusion. An automated sensor is not a self-sufficient witness. It is an object placed in a wet forest full of fungus, insects, corrosion, power problems, and occasional theft, all of which are happy to participate in the experiment whether invited or not. So the real answer is not that modern tools are failing in the sense of being worthless. They fail in a narrower and more important sense. They fail to give complete, cheap, continuous, under-the-canopy certainty at the scale people imagine when they hear words like satellite, drone, or AI. Each tool removes one barrier and runs into another. Optical sensors lose to clouds and canopy. Thermal systems miss hidden fires. Radar sees through weather but not every ecological detail. LiDAR reveals structure but is costly, sample-based, or spatially incomplete. Drones help but struggle with branches, signal loss, lighting, and battery life. Camera traps see behavior through placement bias. Acoustic recorders hear selectively. eDNA widens access but still needs interpretation. Sensor networks reduce human presence only after they survive the conditions that make human presence difficult in the first place. The forest does not defeat technology outright. It forces it into compromise, and that compromise leads to a more interesting conclusion than the simple idea that scientists are still waiting for a better gadget. Some of the limits under the canopy are technical, others are not. Because even when the tools improve, even when the maps sharpen, even when the sensors become smaller and the models become smarter, a question remains that technology cannot answer on its own. Just because we can watch a place more closely does not always mean we should enter it more deeply, disturb it more aggressively, or insist on access where human presence itself carries risk. The next layer of caution in the Amazon is not about weak signals or wet electronics. It is about people, boundaries, and the reason staying away can sometimes be the most responsible decision a scientist makes. By this point, the reason scientists avoid certain parts of the Amazon might seem almost entirely physical. The rivers are difficult, the air is exhausting, the ground is unstable, disease travels efficiently, tools fail in the damp and under the canopy. All of that is true and all of it matters. But there is another reason, and in some ways it is the most important one of all. In parts of the Amazon, staying away is not simply a practical compromise made by tired researchers with damaged equipment and an increasingly philosophical attitude toward wet socks. It is an ethical obligation. It is a decision grounded in law, in public health, and in the recognition that some people living in the forest have very strong reasons for not wanting outsiders to arrive at all. The Office of the United Nations High Commissioner for Human Rights describes indigenous peoples in voluntary isolation as groups that do not maintain regular contact with the majority population and tend to avoid contact with people outside their group, and it treats their protection as an urgent human rights issue rather than a matter of curiosity or exploration. That definition matters because it corrects a very common mistake. Outsiders often talk about uncontacted or isolated peoples as though isolation were merely an accidental condition, like being hard to find, tucked away in remote forest, awaiting discovery by someone with a drone and a very serious face. But official human rights language and state policy in the Amazon increasingly frame the matter differently. Peru's official information on Piasi, its term for indigenous peoples in isolation and initial contact, states that these peoples have a right to self-determination and to decide not to maintain contact with the rest of national society, or to control the degree of contact they wish to have. Brazil's FUNAI likewise describes isolated peoples as groups with no permanent relations with wider society or only infrequent interaction, and notes that their isolation is often linked to traumatic histories of colonial violence that led them to choose social and economic self-sufficiency and to avoid social relations that could trigger interethnic tension or conflict. That is a much more serious picture than the old adventure story language of tribes yet to be found. It means withdrawal can be a historical strategy of survival. The moral consequence is immediate. If a people's distance from the outside world is not a romantic accident, but partly a response to massacre, disease, land theft, coercion, and the memory of what contact has meant before, then the idea that scientists should simply enter in the name of knowledge begins to look less noble and more arrogant. The Inter-American Commission on Human Rights has been very clear that protection of peoples in voluntary isolation and initial contact must fully respect their self-determination, their right to life, their physical, cultural and mental integrity, their health, and their rights to lands, territories and natural resources. The OHCHR's 2025 briefing similarly states that efforts affecting these peoples should begin from the obligation to prevent forced and unwanted contact and to protect their health and way of life. In other words, the first ethical principle is not go and study. It is do not impose yourself. This is one of the quietest but most important reasons certain areas of the Amazon remain off limits or lightly studied. The barrier is not only the forest, it is a human boundary. And unlike a river or a floodplain, that boundary is not something good science should be trying to defeat. In fact, the ethical turn in official policy has been toward contact avoidance, territorial protection, and controlled responses only when absolutely necessary. A World Bank document summarizing Brazil's approach states that Brazil's policy regarding isolated indigenous peoples is based on the premise of not contacting isolated groups and intervening only in specific cases. FUNAI's own official materials say essentially the same thing in more grounded terms. Its teams carry out location and monitoring activities while avoiding any contact, with the stated aim of protecting physical and cultural integrity and avoiding imposed contact that could generate death, precarity and vulnerability. That is not timidity. It is policy shaped by a very painful historical record. The public health reasons for this caution are blunt enough to remove any lingering romance from the subject. Peru's Ministry of Culture describes Piasi as being in a state of high sanitary, territorial, socio-cultural and demographic vulnerability in the face of contact with external populations. Its official campaign materials explain that their immunological vulnerability means their immune systems are not prepared to cope with common diseases because of their condition of isolation or initial contact. FUNAI makes the same point even more starkly, stating that the risk of death stems from a different immunological vulnerability, and that, on first contact, even influenza can kill an entire people. That is not metaphor. It is the kind of sentence that changes the moral balance of the whole discussion. Once you understand that a routine respiratory infection, trivial to an outsider, may become catastrophic to an isolated group, staying away stops sounding passive and starts sounding protective. The vulnerability is not only biological, it is territorial and social as well. Peru's official Piasi materials say, These peoples depend totally on forest resources for survival, so any threat to the territory they occupy directly affects their integrity. The OHCHR briefing links protection of their health to protection of their environment and notes that negative environmental impacts can put them at serious risk. The Inter-American Commission likewise emphasises that their relationship to land is not just an economic matter, but foundational to their collective rights and survival. This is crucial because it changes what protection means. It is not enough merely to avoid walking into a settlement. If miners, loggers, traffickers, missionaries, settlers, or researchers destroy the territory around them, forced contact can happen without anyone physically marching into the middle of a village. Encroachment itself becomes a form of pressure. That is why staying away is so often paired with active territorial defence rather than simple neglect. Brazil's system does not rely only on saying leave them alone and hoping the forest handles the rest. FUNAI states that its protection work is carried out through ethno-environmental protection fronts and permanent or rotating bases of ethno-environmental protection, with expeditions, overflights and ground and air presence used to monitor territories while maintaining distance. It also notes that these units exist specifically to guarantee the self-determination of isolated peoples without contacting them or interfering in their ways of life. The Amazon Fund's description of protection efforts adds that FUNAI has records of the presence of isolated peoples across the legal Amazon and organises technical teams through these fronts to implement localisation and protection policies. So the ethical choice is not ignore them, it is more like protect the territory, prevent intrusion, and refuse to turn human beings into an object of expeditionary curiosity. Peru has built a parallel logic into its own official framework. Its Ministry of Culture states that the country has specific regulations, protocols, and intersectoral protection regime, and intangible reserved areas for Piakti, including indigenous and territorial reserves as well as protected natural areas. The government's 2026 statement says, Peru currently recognises 25 indigenous peoples in isolation, and initial contacts living in 8 indigenous and territorial reserves, covering more than 4 million hectares of Amazon forest. The BDPI portal and the ministry campaign materials spell out those reserve structures in greater detail, listing 6 indigenous reserves and 2 territorial reserves. That tells us something important. The response to vulnerable isolation is not simply send a team to learn more. The response is often legal recognition of territory, restricted access, protective protocols, and the acceptance that the ethical burden lies on the state and outsiders, not on the isolated peoples themselves. Brazil's recent use restrictions make the same principle very concrete. FUNAI states that portarias de restrição de uso, or restriction of use ordinances, are among the main legal and administrative instruments for protecting the rights of isolated peoples. In its 2025 and 2024 notices, FUNAI explains that these measures restrict third-party access and the exploitation of natural resources in specific areas, and that the Supreme Federal Court has ordered uninterrupted and timely renewal of these ordinances for areas with confirmed presence of isolated indigenous peoples. FUNAI explicitly says these restrictions are meant to safeguard life, autonomy, health, and territorial integrity, and that lack of immunity to common diseases is part of the reason such restrictions are fundamental to survival. This is a remarkable inversion of the old frontier mindset. The law is not being used to open the forest to outsiders, it is being used to close outsiders out. There is, of course, a tension here, and it is one scientists feel acutely. Research is normally treated as a public good. Knowledge about biodiversity, climate, hydrology, archaeology, disease ecology and forest change has enormous value, not only locally but globally. Yet in territories used by isolated peoples, the ordinary argument for scientific access runs into an ethical limit. The potential gain in information does not automatically outweigh the risks of disease transmission, territorial disturbance, unwanted observation, or triggering future intrusion by making an area more legible to outsiders. The OHCHR briefing stresses that recognition and protection must be proactive, and that states should urgently pursue and implement the existing guidelines for these people's survival. The IACHR's framework puts self-determination and territorial rights at the centre. Once those rights are taken seriously, science no longer gets to assume that the desire to know is enough. That is why the most responsible scientific stance in such areas is often indirect. Study the forest from the edges, use remote sensing where possible, work with neighbouring indigenous organisations, support territorial monitoring rather than field intrusion, accept that some zones will remain biologically or culturally underdescribed in formal literature, because respecting the people there matters more than satisfying outside curiosity. Funai's own description of its work suggests this posture: building trust at a distance, monitoring from protection bases, and prioritising integrity and autonomy over direct encounter. OHCHR's 2024 statement reinforces the same larger principle in simpler language, calling isolation a strategy of collective preservation and highlighting the need for robust standards on participation, inclusion, safety, and indigenous rights. Once that is understood, the old heroic image of scientists pushing ever deeper into every last unknown patch of forest begins to look not only outdated, but ethically careless. It is also important to say that staying away is not the same thing as pretending these peoples do not exist. One of the gravest historical harms in the Amazon has been the tendency of states, businesses, and sometimes even conservation systems to behave as though remote indigenous presence is uncertain enough to be ignored whenever a mine, a road, a reserve boundary, or an extraction project becomes convenient. The OHCHR briefing states that recognition is central to the protection of rights, because only those peoples whose presence has been recognised in each country's legislation have some degree of formal protection. That makes documentation necessary. It also makes documentation delicate. States need to recognise, protect, and legally shield territories without turning that process into an excuse for unwanted contact. This is one reason modern policy in the region has become so procedural, so full of protocols, reserves, cordons, and administrative acts. The aim is to defend existence without forcing exposure, and exposure is exactly what many isolated peoples are defending against. Funai states that the choice to remain isolated is often connected to traumatic experiences of colonial violence in the past. Its official materials also describe the purpose of its dedicated coordination, which has existed since 1987, as protecting peoples living in remote regions from violence and disease associated with contact with the whites. That timeline matters. This is not a new moral fashion invented by contemporary institutions trying to sound enlightened. It is a policy built out of repeated evidence that direct contact in the Amazon has too often brought epidemics, coercion, land theft, dependency, and cultural devastation. Peru's own framing of Piasi vulnerability echoes this with the language of high sanitary, socio-cultural, and demographic vulnerability. Across the region, the underlying lesson is painfully consistent. Contact has usually benefited outsiders more than the contacted. This is also why official responses to accidental or emerging contact emphasize control, speed, and minimal interference. Brazil's 2025 workshops on strategies for protecting isolated indigenous peoples were described by the ministry as a way to enable a rapid, safe, and coordinated response to contact situations while minimizing risks to collective health and the environment. Funai's 2025 technical group announcement likewise says its teams monitor and locate isolated peoples while avoiding contact, precisely because imposed contact can generate death and vulnerability. The point is not to romanticize permanent distance for its own sake. It is to recognize that if contact happens, it must be handled under strict health and protection protocols, not under the improvisational enthusiasm of outsiders who mistake approach for help. There is a further ethical discomfort that scientists know, even if it is not always spoken aloud. Research can draw attention. Attention can attract funding, headlines, surveillance, tourism fantasies, opportunists, missionaries, illegal actors, and the broader machinery of a society that tends to treat visibility as an invitation. In the wrong context, publishing too much, too eagerly, or too specifically about isolated people's territories can have consequences beyond the paper itself. This is one reason the language of protection is often territorial rather than descriptive. Peru emphasizes reserves and intangibility. Brazil emphasizes restriction of use, interdiction, monitoring, and protection fronts. The ethical task is to keep the area secure, not to turn its inhabitants into the next irresistible subject of public fascination. So when scientists still avoid certain parts of the Amazon, sometimes the wisest explanation is not that they are afraid of what is there, it is that they understand what their presence could mean. The forest in these cases is not merely a hard environment, it is a homeland whose people may have chosen distance with very good reason. The ethical question is not, can we reach them? But, what gives us the right to try? The legal and human rights answer emerging across the region is increasingly firm. Nothing gives outsiders that right simply because they are curious. States are expected to protect life, health, autonomy, and territory. Forced and unwanted contact is to be prevented, and the choice of isolation is to be respected as an expression of self-determination. In a century addicted to access, that remains a surprisingly radical lesson, and perhaps that is one reason the deeper Amazon still gathers so many rumours around itself. Where entry is limited, where silence is protected, where maps do not become full explanations, the outer world begins to do what it always does with boundaries it cannot easily cross. It fills them with stories, lost traces, strange sightings, half-glimpsed histories, and the uneasy sense that just beyond the protected line there may be more than science, law and ethics are yet prepared to describe. There is something about the Amazon that has always encouraged the outer world to become a little unreasonable. A forest this large, this difficult, and this resistant to clean explanation does not merely attract scientists. It also attracts rumour, projection, obsession, and the old human habit of seeing half a fact and quickly dressing it in gold, stone, prophecy, or tragedy. For centuries, stories of hidden cities circulated through Amazonian history. Some were pure fantasy, some were wishful greed in colonial costume, and some, as it turns out, were clumsy distortions of something real. That last part matters. The forest has not been concealing a neat row of marble cities, waiting politely for Europeans, archaeologists, or filmmakers to arrive and gasp. But modern archaeology has shown that large, organised, engineered pre-Columbian settlements did exist in parts of Amazonia, and that the older assumption of a uniformly sparse, untouched wilderness was badly incomplete. A 2023 science study estimated that more than 10,000 pre-Columbian earthworks may still be hidden across Amazonia, while a 2008 science paper on the Upper Singu argued that pre-Columbian Amazonian societies there were organised in articulated clusters with a form of regional urbanism. That is why the ruins and the rumours belong together. The rumours were often wrong in detail, sometimes wildly so, but not always wrong in the deeper sense that the forest had once held larger and more structured human worlds than many later scholars were willing to believe. For a long time, academic thinking leaned toward the view that Amazonian soils and ecological limits could not support dense populations or complex settlement on any broad scale. One reason that view seemed plausible was that much of the region sits on highly weathered, nutrient-poor soils, and yet archaeologists have long known about Amazonian dark earths, or terra preta, fertile anthropogenic soils that stand out sharply from surrounding infertile ground. A classic review in Philosophical Transactions of the Royal Society B notes that these soils occur as highly sustainable fertile patches within otherwise infertile landscapes, have much higher organic matter and nutrient retention than surrounding soils, and are of pre-Columbian origin. Such evidence did not prove every lost city story true, But it did prove that past people in Amazonia were modifying land in durable ways that later observers had underestimated. This is where the old chronicles begin to look less ridiculous than they once did. Early European accounts of the Amazon, especially the 16th century chronicle associated with Gaspar de Carvajal, described long, populous settlements along the river and road-like connections inland. Later scholars often treated such descriptions as exaggeration, partly because the forest visible to later travellers seemed too thinly settled and the soils too poor to support what the chroniclers claimed. But later ecological and archaeological scholarship pushed back against that dismissal. A 2007 ecological paper argued that Carvajal likely did witness dense populations, and that later observers may have seen only the shattered remains of societies devastated by post-contact disease, with mortality potentially in the range of 90 to 99%. That does not mean every dramatic line in every colonial narrative should be trusted. It does mean that the broad possibility of dense settlement was never as absurd as it once seemed. The modern archaeological picture is now much harder to ignore. In southern Amazonia, a 2018 Nature Communications paper reported that an 1,800-kilometre stretch of the southern rim was occupied by earth-building cultures living in fortified villages around roughly AD 1250 to 1500, with the distribution of earthworks estimated over about 400,000 square kilometres. In 2024, a science paper on the Upano Valley in Amazonian Ecuador described a dense system of pre-Hispanic urban centres with monumental platforms, plazas, straight roads extending over great distances, and agricultural terraces and drainages dating from around 500 BCE to between 300 and 600 CE. And in Bolivia's Amazonian lowlands, LiDAR work described by Nature and summarised by Smithsonian revealed major Casarabe urban centres connected by causeways, canals, reservoirs, and monumental architecture. These are not the fantasy cities of colonial treasure maps. They are more interesting than that because they were real, built to local conditions and hidden not by magic but by forest growth, abandonment, and time. Which brings us, inevitably, to the lost city obsession. Once you have an enormous forest, old chronicles, strange mounds, fertile black soils, and the persistent suspicion that the map is not telling the whole story, someone is going to decide they personally must march in and settle the matter. Human beings love a hidden city story with almost embarrassing reliability. El Dorado is the grandest example, though it belongs to a broader colonial fever that mixed indigenous reports, Spanish greed, fear, invention, and the cheerful inability of empire to admit when it was chasing nonsense. National Geographic notes that when the Spanish entered the Amazon basin in the 1540s, they were already recording indigenous accounts of a lost city of fantastic wealth they called El Dorado, and over the centuries many attempts were made to locate such a civilization in the rainforest. Some of those attempts yielded geographic knowledge, hardship, and graves, though not usually the gold part. By the early 20th century, the most famous seeker was Percy Fawcett, and it is hard to imagine a figure more perfectly designed to be absorbed by Amazonian legend. He was not a random dreamer stumbling in from nowhere. National Geographic notes that Fawcett made 7 expeditions in the Amazon basin between 1906 and 1924, worked as a surveyor for the Royal Geographical Society, and spent years crossing borderlands and mapping territory. He was experienced, physically resilient, and deeply convinced that a lost civilization existed in central western Brazil. He called it Zed. He was also, like many explorers of his era, a man shaped by colonial assumptions, selective reading, and a dangerous degree of confidence in his own interpretive powers. Part of Fawcett's obsession was fed by a document known as Manuscript 512, an alleged 18th century account describing a ruined city with monumental features somewhere in Brazil. National Geographic notes that the manuscript fascinated Fawcett, but that scholars remain divided on its authenticity, with some considering it a forgery. It also notes that Fawcett did not actually expect to find the city exactly as described in that manuscript. Instead, drawing on various historical sources, he became convinced that a lost civilization existed in Mato Grosso. This is the key point. Fawcett was not only chasing a single map reference like a man in a melodrama, he was working from a bundle of reports, convictions, biases, and genuine geographical gaps. That is partly why his story remains interesting. He was not wholly insane. He was just wrong in the way determined people often are, close enough to a truth to become much more dangerous to themselves. In 1925, he vanished. National Geographic reports that Fawcett disappeared that year in the Mato Grosso region of Brazil while searching for Zede, accompanied by his son Jack and Jack's friend Rolly Rymel. His disappearance became one of the Amazon's enduring mysteries. Rumours followed quickly and multiplied with the efficiency only a missing explorer can produce. Claims surfaced that he had been killed, had survived among indigenous communities, had reached his destination and chosen not to return, or had become the victim of some error so ordinary it offended the appetite for legend. National Geographic also notes that a 1952 announcement that Fawcett's bones had been found was later undermined by forensic analysis showing the remains were not his. So the mystery remained, and because the forest rarely offers neat endings, mystery was enough to keep the story alive. The strange thing is that modern archaeology has partly vindicated the general shape of Fawcett's intuition, while leaving his own fate completely unresolved. National Geographic reports that later work in northeastern Mato Grosso uncovered the remains of large urban settlements in what is now Singu Indigenous Park, including the complex called Kuhikugu, with remnants of streets, bridges and large squares. It also notes that modern LiDAR scans suggest this region was indeed the site of large settlement between roughly 1,500 and 400 years ago. So Fawcett's exact city Zede may have been imaginary, misplaced, or overly romanticised, but the broader idea that parts of Amazonia held substantial settled societies was not foolish after all. This is a very Amazonian outcome. The man may have been wrong in method, wrong in details, and fatally wrong in judgment, yet not entirely wrong in premise. The forest, as usual, refused to grant anyone the simpler version of the story. If Fawcett represents the Amazon as obsession, the Roosevelt-Rondon expedition represents it as punishment applied to confidence with scientific paperwork attached. In 1913 and 1914, Theodore Roosevelt joined Cândido Rondon on what Smithsonian describes as the descent of the Rio da Dúvida, the River of Doubt which Rondon had encountered in 1909. At the start of the river descent, no one knew how long the river was, what terrain it crossed, or where its waters ultimately discharged. The principal focus of the journey was cartography and terrain, utterly unknown to either science or geography, and Roosevelt understood that it offered a substantial addition to geographical knowledge. This is worth pausing over, because it reminds us that some of the Amazon's most famous expeditions were not treasure hunts at all. They were scientific and geographical ventures. They still nearly killed everyone involved. The descent quickly became the kind of enterprise that politely removes glamour from the word expedition. Smithsonian reports that Rondon's team, lacking GPS and aerial mapping, used compass and solar observation and had to stop 114 times on the first day, advancing barely 7 miles while recording the river's course. The boats were leaky, the river twisted unpredictably, and the labour fell heavily on Brazilian camaradas who paddled, portaged, hauled equipment, and worked with extraordinary endurance. A few days later, in rapids, a canoe overturned and Antonio Simplicio da Silva drowned, with the canoe and supplies lost. Later the party endured swollen feet, fever, dwindling food, repeated portages, dangerous rapids, and growing internal tension. Roosevelt himself gashed his leg, developed a serious infection, became delirious with fever, and at one point told Rondon to leave him behind because he could not go on. This is not the sort of detail one adds for drama. It is the practical shape of what happens when maps run out before the river does. The journey also picked up exactly the sort of grim human detail that later stories often smooth into legend. Smithsonian's account records that, amid hunger and collapsing morale, a paddler named Julio de Lima was caught stealing food repeatedly and later murdered the Corporal Manuel Vicente de Paixão before fleeing into the jungle. The expedition also encountered signs of nearby indigenous groups and remained alert to attack, though Rondon insisted on leaving gifts and maintaining peaceful intentions. By the end, the descent had produced major geographical knowledge, but it had also confirmed something less flattering and more durable. The Amazon does not care whether your mission is scientific, noble, presidential, or accompanied by excellent stationery. It remains perfectly capable of drowning a man, breaking a leader, encouraging murder inside a starving camp, and then continuing downstream as though none of that were its problem. This is one reason lost expeditions linger so strongly in Amazonian memory. The forest is unusually good at removing evidence. Boats rot, trails vanish, camps are reclaimed, bones are hidden, scattered, consumed, or never found. A person can disappear there in a way that leaves behind just enough trace to feed myth and not enough to settle it. Fawcett became a legend because he vanished while pursuing an idea already wrapped in legend. Roosevelt became a legend because he nearly died while doing something scientific enough to sound respectable and dangerous enough to sound biblical. Around both stories sits the same lesson. The Amazon is a bad place to assume that determination will be rewarded with closure. And closure in truth is not really what the archaeology offers either. It offers correction, not closure. The old picture of the Amazon as a place of tiny, uniformly dispersed, low-impact populations has been revised sharply by evidence of fortified villages, regional settlement systems, engineered soils, earthworks, roads, canals, reservoirs, and substantial landscape modification. The 2018 Nature Communications paper on southern Amazonian earth builders and the 2024 Science paper on Upano both point to large, organised settlement networks. The 2023 Science estimate of more than 10,000 hidden earthworks suggests that archaeologists have probably identified only a fraction of what remains. Yet that does not restore every colonial fantasy. It does not give us El Dorado, Roman spires, or the simple idea of one grand metropolis waiting beneath the leaves. What it gives us is something more demanding. The Amazon held many kinds of societies, distributed unevenly, adapted to local ecologies, and often far more engineered than later outsiders assumed. That is harder to turn into myth because it is more interesting and less tidy. There is also a humbling point here about rumour itself. Rumour survives in the Amazon because visibility is poor, access is partial, and evidence often arrives long after the story has begun. A traveller sees a mound, a dark soil patch, a cut bank revealing pottery, or an oddly straight rise in the land, and the mind races ahead. Perhaps a city, perhaps treasure, perhaps giants, priests, roads, curses, kingdoms, or some other familiar human attempt to make uncertainty more exciting than it needs to be. Science eventually arrives with survey grids, radiocarbon dates, LiDAR, excavation units, paleoecology, and the grim determination to ask fewer glamorous and more useful questions. But the rumours are not entirely wasted. They tell us where perception once snagged on something real. The trouble is that perception usually adds far too much gold leaf to the snag. So when scientists still avoid certain areas of the Amazon, the ruins and the old expedition stories are part of the reason, though perhaps not in the way people first imagine. It is not simply that researchers are worried about vanishing like Fawcett, though no sensible person would volunteer for that kind of sequel. It is that the forest has repeatedly shown how easily fragile knowledge can be replaced by alluring nonsense, when access is hard and evidence is scarce. Archaeology in Amazonia now proceeds with more caution, because the stakes are different. A mound may be an earthwork, a patch of dark soil may mark centuries of occupation, a straight corridor in LiDAR may be a road or causeway, a riverbank may hold ceramics, burial sites, or traces of a settlement erased from ordinary view. The deep forest is no longer just a place where adventurers might project fantasies. It is a place where hurried intrusion might damage real and irreplaceable records of human history, and that changes the tone completely. Once the rumours begin giving way to evidence, the Amazon stops looking like an empty stage for heroic trespass and starts looking like an archive. Not a tidy archive with labels and controlled lighting, but an active, living archive spread across floodplains, uplands, indigenous territories, protected areas, unstable soils and forests that continue to grow over the very things scientists hope to understand. The ruins do not merely invite discovery, they also demand restraint. Because the next question is no longer whether the deep forest contains traces of older worlds. We already know that in many places it does. The next question is what scientists worry they might damage, unsettle, expose, or permanently alter when they go looking too aggressively. And that is where caution begins to deepen from inconvenience into something much more serious. By the time scientists speak honestly about the deepest parts of the Amazon, the tone often changes. The conversation stops being about what might jump out of the shadows and starts being about something much less theatrical and far more serious. The question is no longer only, what could the forest do to us? It becomes, what could we do to the forest, to the people inside it, to the animals watching from it, and to the history buried under it, simply by arriving? That is a different kind of fear. It is steadier, less cinematic, and in many ways more mature. It comes from the recognition that in a place already under pressure, a research team can be more than an observer. It can become a disturbance. And once you see the Amazon that way, the old image of science as a harmless flashlight sweeping into the dark begins to feel much too flattering. The forest is not waiting in some neutral state for us to look at it. Large parts of it are already vulnerable to degradation, and those vulnerabilities do not disappear just because the people entering have good intentions and laminated permits. A 2023 science review estimated that about 2.5 million square kilometres of Amazon forest are already degraded by fire, edge effects, timber extraction, and extreme drought, representing roughly 38% of the remaining forest, with carbon emissions from degradation comparable to or greater than those from deforestation. That figure matters because it changes the emotional weather around fieldwork. A scientist entering an intact or relatively intact part of the Amazon is not stepping into a limitless wilderness, where one more camp, one more trail, one more season of repeated access could not possibly matter. They are entering a biome where degradation is already widespread and where even subtle changes can accumulate into edge effects, altered fire risk, changed hydrology, and biodiversity loss. The science review found that degradation can reduce dry season evapotranspiration by up to 34% and can cause as much biodiversity loss as deforestation in human-modified landscapes. That does not mean a careful research party is equivalent to a logging operation, because it plainly is not. But it does explain why experienced scientists become cautious about being the first repeated human presence in a place that has remained comparatively undisturbed. The problem is not one tent or one transect in isolation. The problem is that human access has a habit of expanding beyond the first reason it was created. One of the clearest examples of this is access itself. A path through the forest is never just a path. It is information made physical. It says that movement is possible here, that entry is manageable here, that the forest can be crossed from this riverbank or that ridgeline or this patch of drier ground. Scientists know that very well because they depend on exactly that kind of hard-earned knowledge. The uncomfortable part is that once such knowledge exists, others can use it too. Research on illegal use of resources in federal protected areas of the Brazilian Amazon found that accessibility was one of the key factors shaping pressure on protected areas, and the study defined accessible areas precisely in relation to roads and rivers because transportation limits most exploitation in the Amazon. The same study evaluated 4,243 law enforcement records and found that the most common illegal activities were suppression and degradation of vegetation, illegal fishing and hunting. In simple terms, where people can get in, pressure tends to follow. That pattern becomes even sharper once roads or easier routes appear. A +1 study on road development and hunting by an Amazonian indigenous group found that the presence of roads was associated with a twofold increase in the extraction area, and that road placement within protected areas can seriously reduce their ability to sustain wildlife populations. That is the sort of result that stays in a scientist's mind long after the paper is closed, because it suggests that access is not neutral. It changes hunting geography, extraction intensity, and the relationship between wildlife and people. So when researchers hesitate to cut new paths, publicize exact routes, or normalize repeated travel into little disturbed zones, part of what they are fearing is not the walk itself. They are fearing the afterlife of the walk. Someone else may come later for a very different purpose and use the same opening much less gently. This is one reason archaeological work in the Amazon has become so ethically careful. The forest is not only alive in the present, it is full of buried human records that can be damaged by too much visibility just as easily as by too little protection. Modern archaeology has shown that Amazonia contains extensive pre-Columbian earthworks, engineered landscapes, roads, settlements, and anthropogenic soils, which means researchers are no longer dealing with a simple question of whether anything is there. They are dealing with the problem of how to study sensitive sites without exposing them to damage, vandalism, or looting. A 2020 paper in Advances in Archaeological Practice states that archaeologists must balance calls for open data with the need to maintain confidentiality of sensitive site locations, and notes that researchers are ethically and often legally bound to obscure or not disclose coordinates when site security is a concern. UNESCO in turn states that theft, looting, and illicit trafficking of cultural property are crimes that deprive people of their history and culture, and that illegal excavations erase scientific and historical knowledge. Once a site is looted, the objects may survive, but the context, which is where much of the knowledge lives, is torn apart beyond repair. That is why, in some parts of the deep forest, what scientists fear disturbing is not just the site itself, but its visibility. A mound, a causeway, a plaza, a patch of dark earth, a pattern in LiDAR, or a line of raised terrain may be scientifically thrilling and publicly dangerous at the same time. Archaeologists have become careful about how they map and share location data precisely because a sensitive site can become more vulnerable the moment it becomes legible to the wrong audience. It is one of those awkward cases where science wants to publish and protect at once, and the two impulses do not always sit comfortably together. The fear here is not mystical, it is practical. A careless map can do what a spade should never do. It can turn a buried archive into a target. Then there is the matter of wildlife, which is not merely present in the forest but actively responsive to human attention. This is where caution becomes even more uncomfortable, because scientists are trained to observe animals closely, and close observation is not always harmless. A long-standing primate conservation literature warns that some field research methods, especially those involving close proximity, habituation, or inadequate sanitation, may place wild primates at risk of acquiring human-carried diseases. A broader review on human-wildlife contact states that transmission of infections between humans and non-human primates is exacerbated not only by local communities and tourists, but also by park personnel, researchers, filmmakers, and photographers. The same review notes that habituation to human presence can make wildlife more vulnerable to poaching because of their reduced fear of humans, and that increased human-wildlife contact can contribute to the transmission of bacteria, protozoa, viruses, and helminths. In other words, even when people arrive with binoculars instead of guns, they can still alter the animals they are trying to protect. That point can sound abstract until you put it in concrete terms. If animals learn that humans are not immediately threatening, they may become easier for the next, less benevolent humans to approach. If researchers camp carelessly, dispose of waste poorly, or spend long periods in close proximity to primates. They may introduce pathogens that the animals have little defense against. If repeated visits normalize a route, hunting pressure may later increase in the same area. If a study site becomes well known, the very species being documented can become more exposed to disturbance, collection, or opportunistic exploitation. The fear, then, is not simply of disturbing a single monkey or a single nesting site in the obvious moment. It is of changing the larger relationship between wildlife and human presence in a place where fear of humans may still be one of the best protections animals have left. There is also a disease dimension that runs in both directions, and scientists know it all too well. We often think of the Amazon as a place where humans risk infection from wildlife, vectors, and forest pathogens. That is true. But the reverse is also true. Humans can carry microbes into wildlife populations, and the breakdown of natural barriers between people and animals can intensify broader disease risks. The review on human-wildlife contact describes non-human primates as highly susceptible to many human infections, and identifies human-driven contact as a major factor in pathogen transmission between species. This is not just a primate tourism issue in Africa or Asia. It is a general lesson for any forest where humans and wild primates or other mammals are brought into repeated close contact. For Amazon science, that means a deep forest site is not just a place to collect data. It is a possible exchange zone, and exchange is not always a polite word in epidemiology. If that sounds discouraging, it is meant to sound sobering rather than hopeless. Science does not stop because of these risks. It adapts. Researchers use masks around certain wildlife, tighten camp hygiene, increase distance, rely more on camera traps and passive sensors, avoid habituation where possible, and treat field protocols as part of conservation rather than a bureaucratic afterthought. But the unease remains, because no protocol turns a human body into a neutral object. People shed microbes, odours, noise, routines and signs. They compress vegetation underfoot. They create predictable paths. They leave traces of salt, smoke, waste, fabric fibres, batteries, tape and familiarity. In many environments that footprint is modest and manageable. In a deep forest site with little prior human presence, it can feel less modest than researchers would like to admit. And then there are the people we have already spoken about, though they remain impossible to leave out here. In territories used by indigenous peoples in voluntary isolation or initial contact, the fear of disturbance becomes moral and immediate. In those cases, scientists are not merely worried about trampling a study plot or spooking a troop of monkeys. They are worried about bringing respiratory infections, influenza, measles or other pathogens into populations with very high immunological vulnerability, and about violating the self-determination of peoples whose choice of distance is itself a strategy of survival. The reason this belongs in the present section is simple. The most serious thing in the deep forest that a scientist may disturb is not always ecological. Sometimes it's human life on terms set by people who never invited the encounter in the first place. That is why official protection policies in Brazil and Peru prioritize avoiding contact, monitoring territories at a distance, and restricting access. In such places, restraint is not the enemy of knowledge. It is the minimum condition of decency. There is a further worry, one less visible than disease or looting but just as real. Scientists often rely on the deepest forest as a baseline. They need places where ecological processes are less modified, where animal communities are less reshaped by roads and extraction, where carbon stocks, tree mortality, soundscapes, flood cycles and species interactions still resemble something closer to old conditions. As the 2023 Science Review makes clear, large parts of the Amazon are already degraded by fire, drought, timber extraction and edge effects. That means the remaining less disturbed areas are not just biologically important, they are scientifically precious, they are comparison sites, they are reference systems. And once such a place is altered even slightly, the value of that comparison can be weakened. The fear here is not dramatic. It is the fear of contaminating the very thing that lets you measure change honestly. A baseline, once disturbed, has a nasty habit of no longer being a baseline. This is part of why the best field scientists often sound less triumphant than the public expects. They know that going deeper is not always the same thing as doing better. Sometimes the highest form of care is to sample lightly, publish cautiously, obscure exact coordinates, minimise visits, collaborate with local and indigenous guardians, and let the forest keep some of its practical opacity. That can feel unsatisfying to outsiders who want every mystery cleared up neatly and every map filled in. But a forest under this much pressure does not benefit from every mystery being converted into a route, a coordinate, or an itinerary. There are cases where more precise knowledge in the wrong format becomes a tool for future damage. Researchers fear that not because they are sentimental, but because they have watched access, exposure, and exploitation reinforce one another before. So the thing scientists fear disturbing in the deep forest is not one thing, it is a chain. It is the chain that links access to pressure, visibility to looting, observation to habituation, proximity to disease, and repeated presence to ecological change. It is the possibility that a careful expedition could become the first step in a much rougher sequence. It is the knowledge that deep forest still contains living communities, vulnerable wildlife, buried human histories, and comparatively intact ecological reference points that are harder to restore than to damage. It is, in the simplest terms, the fear of becoming the problem in a place you came to understand. And once you sit with that for a moment, the final piece of the story begins to feel a little less mysterious. The deepest parts of the Amazon are not silent because nothing is there. They are silent because so much is there, and because some of it is safer, truer, or more intact when approached with distance. That is why the forest can still seem to withdraw from us even when we have better maps, better sensors, and better models than ever before. Sometimes the most responsible science does not sound like conquest. It sounds like backing away a little, lowering the noise, and admitting that beneath the leaves there are still places where the last thing needed is one more set of boots. And so we come at last to the kind of silence that is easiest to misunderstand. From far away, the deep Amazon can seem quiet in the same way a closed door seems quiet. You look at the surface, see no movement that makes immediate sense to you, and assume that not much is happening on the other side. But the silence beneath the leaves is rarely the silence of absence. It is usually the silence of density. Too much life, too much distance, too much water, too much history, too many boundaries, too many signals blocked by wood, cloud, mud, rain, and caution. The Amazon is one of the largest rainforests on Earth, covering about 2.7 million square miles in the basin and holding about 1 in 10 known species, which already makes the idea of fully knowing it feel less like a task and more like a very ambitious personality trait. That is perhaps the first thing worth carrying away from all of this. The forest is not withholding itself because science has failed in some dramatic or embarrassing way. It is not sitting in the dark smugly undefeated by helicopters, satellites, lasers, maps, laboratories, and the peculiar human confidence that every problem can be solved, with enough equipment and a grant proposal written in the right font. The forest remains partly unknown because it is very large, physically difficult, biologically crowded, historically layered, and ethically complicated. Those are not the same as mystery in the cheap sense. They are the ordinary conditions of a place that does not simplify itself for outsiders. A great deal of the world has been flattened by access. Roads arrive, grids appear, a river becomes a transport corridor, then a supply corridor, then a commercial corridor, then a whole chain of settlements, clearings, markets, and consequences. Forests shrink, species retreat. Knowledge grows in one sense while the thing being studied shrinks in another. The Amazon has not escaped that process, and it would be dishonest to pretend otherwise. Research published in Science concluded that around 38% of the remaining Amazon forest has already been degraded by fire, edge effects, logging, or extreme drought, and that degradation can cause carbon emissions and biodiversity losses on a scale comparable to or greater than deforestation in some settings. That matters because it means the remaining deeper, harder, quieter parts of the forest are not only scientifically interesting, they are increasingly important as places where ecological processes still persist, with less direct alteration, so the silence matters. It matters because it is under pressure. It matters because once certain kinds of disturbance arrive, they rarely leave politely. A road does not simply arrive and stop being a road. A new route becomes a habit. A habit becomes access. Access becomes extraction for someone eventually, whether that someone is a logger, a miner, a hunter, a trafficker, a tourist, a missionary, a researcher, or the sort of person who hears the phrase previously undocumented site and unfortunately interprets it as a personal invitation. Scientists know this. That is why caution in the deep forest often sounds less like fear of what is hidden there and more like concern over what visibility itself can trigger. There is another kind of silence in the Amazon too, and it does not belong to trees. It belongs to people who have decided, for reasons history has made tragically understandable, that distance from the outside world is safer than contact with it. The UN human rights system describes indigenous peoples in voluntary isolation and initial contact as groups that do not maintain regular contact with the majority population, and emphasises the need to prevent forced or unwanted contact. That language is careful for a reason. These are not communities waiting to be found so they can complete someone else's story. Their distance is often tied to histories of violence, disease, dispossession, and survival. In those cases, staying away is not a failure of science or curiosity. It is respect, and in some cases, it is a matter of life and death. That is one of the hardest lessons for modern people to accept. We are used to thinking that more access is automatically better, more information automatically good, more visibility automatically helpful. But there are places where seeing more can hurt more. There are places where mapping too neatly, entering too casually, publishing too eagerly, or treating every hidden area as a challenge to be overcome can make a bad situation worse. In territories used by isolated peoples, the most ethical act a scientist may perform is to stop, back away, and let protection mean what it should mean. Not entry, not contact, protection. And even where no such human boundary exists, the forest still asks for restraint. It is full of the sort of evidence that can be damaged merely by being turned into a destination. Modern archaeology has shown that Amazonia contains far more traces of large pre-Columbian earthworks and engineered landscapes than scholars once believed. A 2023 science study estimated that more than 10,000 pre-Columbian earthworks may still remain hidden throughout Amazonia. That should change the way anyone thinks about the phrase empty forest. It was never empty in the way outsiders imagined. It held people, roads, earthworks, managed soils and settlement systems, many of them later erased from easy sight by collapse, disease, regrowth and time. The quiet in some places is not a blank, it is an archive. There is something humbling in that. People have been wrong about the Amazon in opposite directions at different times. First, many imagined it as a place of glittering hidden empires waiting to be plundered, which was fantasy. Later, many imagined it as a thinly inhabited wilderness, too poor to support complex societies, which was also incomplete. The truth turned out to be more demanding, not gold cities, not emptiness, something messier and more intelligent. Human landscapes adapted to local ecologies, altered over generations, then partly hidden again beneath a forest that does not preserve human memory in the neat stone language some archaeologists might prefer. That is one reason the last silence beneath the leaves feels different from the silence of, say, a deserted building or a remote mountain valley. It is not stillness in the sense of nothing happening. It is active life and layered history operating on scales that do not always include us. A scientist may stand in one patch of forest and hear insects, a bird call, perhaps distant water, perhaps branches moving somewhere beyond sight, and still know that the place exceeds immediate perception almost completely. Above there is canopy. Below there are roots, fungi, buried ceramics perhaps, hidden insects certainly, bacterial worlds, stored carbon, dark soils in some places, poor soils in many others, seeds, rot, humidity, tracks, spore, and everything else. The human eye fails to notice on first, second, and 10th encounter. Modern tools help, of course. They help enormously. Satellites show broad changes. Radar works through clouds better than optical sensors. LiDAR reveals structure hidden under canopy. Genetic methods pick up traces life leaves behind. Acoustic monitoring can hear what a hurried person would miss. Yet each tool still arrives with limits. Clouds obscure, canopies conceal, batteries fail, tracks are incomplete, samples are partial, and the larger problem remains. The Amazon is not just one question waiting for one instrument. It is a stack of questions layered on top of one another, and the answers are often local, conditional, and slower to assemble than modern culture likes to tolerate. This is why experienced scientists often sound a little gentler and a little less triumphant than popular adventure stories would suggest. Real field science in the Amazon does not reward swagger very well. It rewards patience, collaboration, caution, long-term observation, respect for local expertise, medical discipline, and a willingness to admit what cannot yet be known safely or properly. It also rewards humility, though that particular reward tends to arrive disguised as inconvenience, failed equipment, fungus in the wrong case, or a river level that has decided your timetable was an amusing fiction, and still they go. Or more accurately, they go where they can, and where they should, and where they can do so without becoming the worst thing in the story. That distinction matters. Scientists are not avoiding certain areas because they are uninterested. They avoid them because interest is not enough. Sometimes the route is too difficult. Sometimes the health risks are too high. Sometimes the legal protections are clear. Sometimes isolated peoples must be left alone. Sometimes a site is too vulnerable to exposure. Sometimes the likely damage of opening a path is greater than the likely gain of entering. Sometimes the data can be gathered indirectly. Sometimes they cannot. Sometimes the right answer is not go deeper, but be more careful. That is a mature kind of curiosity, though it rarely looks as dramatic on screen. It is easier to tell stories about conquest than restraint. It is easier to make a hero out of someone hacking toward the unknown than someone reading a protection protocol, refusing a route, masking around wildlife, withholding sensitive coordinates, or deciding that the most ethical field season is the one that disturbs least. But if the question is why scientists still avoid certain areas of the Amazon, the truest answer is not that the forest is spooky. It is that the forest is alive, inhabited, vulnerable, and not obliged to become available just because we've developed better machines. There is, I think, a comfort in that, though perhaps not the loud sort. In a century where so much has been scanned, tracked, indexed, bought, measured, uploaded and explained too quickly, it is strangely reassuring that there are still parts of the earth where knowledge has to move carefully or not at all. Not because ignorance is noble, it is not, but because some things should remain difficult until they can be approached responsibly. Difficulty can be a form of protection. Friction can be a kind of mercy. The last silence beneath the leaves may survive in part because the forest still makes easy access expensive, and because some boundaries are now defended not only by mud, heat, and river distance, but by better ethics than the world once had. None of that means the Amazon is safe. It is not. The pressures on it are real, and they are not slowing simply because the forest is impressive. A place can be globally admired and locally damaged at the same time. It can hold immense biodiversity and still be degraded piece by piece. It can contain cultural histories not yet fully documented, and still lose them to fire, looting, extraction and exposure. It can shelter peoples who choose isolation and still be encroached upon by outsiders who do not care. Silence does not guarantee protection. Sometimes it only means the damage has not yet reached the point where everyone else has decided to notice it. That, perhaps, is why this final quiet feels heavier than the beginning. At the start, the Amazon can seem like a grand puzzle, a place scientists avoid because it is physically hard and perhaps a little intimidating. By the end, the picture is less romantic and more serious. The forest is not simply difficult, it is burdened. It is carrying extraordinary biological wealth, human histories both ancient and living, and the pressure of being important to a world that has not always been particularly kind to important things. The last silence beneath the leaves is not only what remains unknown, it is also what remains unbroken, what remains unforced, what remains unentered, and what remains, for the moment, not yet flattened into someone else's convenience. So perhaps the most honest way to end is with less certainty than people usually expect from a documentary voice. Scientists will continue to study the Amazon. They should. There is too much at stake not to. They will map more of it, hear more of it, sample more of it, and revise their assumptions many times over. New species will still be described. New archaeological features will still be identified. New models will sharpen. New warnings will be issued. New parts of the forest will become more legible than they once were. But full possession of the place in an intellectual sense still seems unlikely, and perhaps that is not a tragedy. Perhaps it is a reminder that understanding is not the same thing as ownership, and that knowledge at its best includes the discipline to stop where stopping is wiser. And so the forest remains there, vast, damp, crowded, and difficult, breathing under cloud and canopy, holding species, rivers, stories, reserves, buried roads, hidden earthworks, protected peoples, failing signals, and enough unanswered detail to keep science humble for a long time yet. The leaves close overhead, the paths thin out, the sound changes. Then there is that final kind of quiet again, not empty, not simple, not ours, but still there. If this long journey through the Amazon has given you a little calm, or a little wonder, or simply the pleasant feeling of having wandered somewhere immense without having to dry your socks afterward, then a like and a subscription would be very warmly appreciated. And for now, wherever you are, whatever hour has gathered around you, let the room grow a little softer if it wants to. Some parts of the world are still not asking to be conquered. They are only asking to be understood carefully from the right distance, while the last silence beneath the leaves is still allowed to remain.